Well, welcome today. I'm glad to be here today at the HVAC Technical Education Conference. Thank you very much for showing up today. I'm going to talk to you about Copeland compressors. A little bit about me. My name is Trevor Matthews. I'm the technical trainer for Emerson Canada. So my role is to work with contractors, OEMs and wholesalers all across the country to help develop them in their skills with Copeland compressors, ALCO controls, Dixel controls. We have teams that training teams that do filter compressors, electronics teams as well. So that's a bit about the role that I play. A bit of my experience. I've been in an industry for about 15 years. My background is mostly in supermarket refrigeration, but I've branched off and doing industrial gas fitting. I've done AC work, HVAC work, and a lot of different applications I've worked in. For the last 5 years, I've been working with Emerson, and with Emerson, my first role was business development, working with contractors, showing them different solutions from Copeland solutions, electronic solutions. And about 2 or 3 years ago, they developed a role for me as the technical trainer. So the last 3 years, we've been developing technical training across Canada to help the contractors out there, the mechanics out there, feel confident and understand the equipment they're working on. Today, we have a lot of heavy hitters in the room. So what I really want to do is share a lot of knowledge with you. I'm probably going to learn a lot more than you guys are going to learn, to be honest with you. We got Don Gillis. Don Gillis leads the training for the educational service in the U.S. And as well as we have Dave Dunn in the back as well. He does all the Copeland trainings as well in the U.S. Some of the things that I want to let you guys know about, and I want to start this right off, is that Emerson really believes in training. They really believe in helping our customers out, technical training, to make sure that you feel confident and you understand the product that you're working on, installing, servicing. So right here, I just want to kind of show you some of the Emerson training in North America that Emerson does. On the left-hand side here, this is a calendar of all the trainings that happen in the U.S. that Don and Dave do. And one good thing, I have the links right down below here for the instructor-led courses. You can subscribe to this calendar, and when you subscribe to this calendar, you will find out all the different technical trainings that Emerson does across the United States. Don and his team travel over 36 weeks a year doing technical trainings, from Copeland trainings, supermarket trainings. He has a team that does E2 trainings, as well as, what's a few other trainings you do?
Anything from 4-hour courses to 5-day courses, from getting people certified as Copeland technical specialists to basically Copeland half-a-day class and just the anatomy of, and anything fundamental. Anything
fundamental. So I highly recommend. Today we're going to do a 3.5-hour course. I'm going to do my best to share as much knowledge as possible. But the learning doesn't stop here. I highly recommend you make it out to these technical courses. Our Copeland authorized distributors, they put on these courses all across the country. Talk to your distributors. Say, listen, I want to get a supermarket course in here because my team does a lot of supermarket work. Or I need a E2 training. Can we get some E2 training? Okay? So these seminars are very important to build your knowledge and your skills. On the right-hand side is our course schedule for Canada. So as you can see, we do Copeland compressor trainings, we do electronics training, modulation training, natural refrigerants trainings, we do E2 trainings, filter industrial compressor trainings, as well as heating and cooling trainings. So when I started at Emerson, my first year, I believe we did 6 to 10 trainings that year. Last year, we did over 78 training dates, technical trainings that help our customers, and it's growing all the time. So really get out to these events, be there, and ask lots of questions, especially today. I really want to have an interactive group. I hope, to be honest, I hope I don't finish all the slides. I hope that we have such a good conversation that you guys learn. That's how everybody learns. You know, you'll learn asking questions, and be honest, I won't have all the answers. You know, I do have some knowledge, and I learned a lot over the last 5 years. Like I said, I've been in an industry for 15 years, but the last 5 years I've been inside and outside of Copeland compressors. And I want to share this knowledge with all of you. So down below would be the Canadian link to all the Canadian trainings. So if you have people that you work with in Canada, or if you're from Canada, attend some of these events. They're all across the country as well. So I want to talk a little bit about Emerson to give you an understanding who Emerson is. Because when I started and I came to Emerson, I knew one thing, Copeland, as a mechanic. But after a few years with inside Emerson organization as a mechanic, I'm like, we have so many great products that our customers don't know about. 5 years ago, we had 5 different platforms. We're 5 different divisions. 2 or 3 years ago, we turned into a one Emerson. Now we have 2 different platforms. One called Automated Solutions. This is more in industrial, as you can see, oil and gas refinery, power plants, nuclear power, life sciences. Really, measurement and analytical instrumentation, control valves, actuators, solutions, the Internet of Things. And we're talking big plants. Appleton, great company. They built lots of different NEMA rating boxes. So if you ever work in a plant, so a lot of my contractors, they work in plants. I worked in a place called Fort McMurray in Canada. Some people call it oil sands. A great place to learn, get experience. And it was a plant. So working on the plant, you need a lot of these explosion-proof boxes. So Appleton is a company that could provide that, right? Because I have contractors call me up. I got a special application. I need this. I don't know that product inside out, but I know who the contact is to help you guys out. Then ASCO. ASCO is another one. How many people heard of ASCO? Show of hands. So we got a few people in here that heard of ASCO. Well, that's an Emerson-owned company. We see them, our distributors sell like the valves, solenoid valves for gas. Bettis, I don't really know much about Bettis. Branson's a laser company, so they can cut plastics and stuff, super cool. Delta V is a massive massive control platform that you can see a lot of different sensors and points into one location. Fisher, how many people heard of Fisher? Let's show hands of Fisher. Oh, a lot more hands go up, right? So in Canada, we have a lot of gas, natural gas. So you'll see a lot of Fisher valves. Micromotion is analytics, measurement, as well as Rosemount. How many people heard of Rosemount? Flow, yeah, you heard of them? Yeah, exactly. You used to put micromotion in too? Okay, see how Emerson owns a lot of these companies. They might not directly be related to you on a day-to-day, but you might have a customer that is in need of one of these products. Really reach out to your Copeland authorized wholesaler to get in contact with the Emerson representative, right? And that Emerson representative might not know who Rosemount contact is, but they can work with you to find that out, to service you. Any questions on our Automated Solutions division? Because this is a large division. No? Okay. So this is our Emerson Commercial Residential Solution. This is the bread and butter for me. On a day-to-day basis in Canada, I am working on these brands and these solutions. And some of them that you may know, some of them you may not know, and some of them will surprise you that Emerson owns these companies. So we're really in residential, light commercial, commercial application, and industrial applications. So heating and air conditioning, thermostats, refrigeration, facility controls, lots of different products we have. We're one of the largest refrigeration and HVAC product manufacturers in the world because we own so many different companies. Emerson owns over 60 different companies that do a wide variety of things. Some of our brands, Copeland, we're going to talk a lot about Copeland today. When you leave here today, I'm hoping you have a great knowledge, at least you learn one thing from me. If you can learn one thing from me today and share that with someone, I know I did my job well. But Copeland we're going to talk about quite well today. White-Rodgers is another division. So if some of you, how many people have heard of White-Rodgers before? Almost everybody's hand go up. Great, that's a division under Emerson. They just actually took over all our flow products as well. So our TX valves, our system protectors. Great company, great products. We'll talk about them a little bit more. Vilter. Anybody here do any industrial stuff or heard of Vilter before? The one guy, two. Okay, two people. So they build compressors, large compressor, hundreds of tons. So they build a single screw compressor as well as a reciprocating compressor. We do full day, 2-day trainings on these compressors for our contractors to make sure they get in there and do that hands-on work, doing the maintenance, doing all the specs on these compressors to make sure when they leave that training, they can start implementing the things that they learned the next day out in the field. Dixel is an electronics control company out of Italy. How many people heard of Dixel? Show of hands. So almost half the room. So you might see Dixel components and don't even know Emerson owns this company. A great company that builds a lot of different controllers for case controllers. They build rack controllers, monitoring controllers. Alco out of Germany. There's another electronics control company that we own. Anybody ever hear of Alco? How about Emerson electronic valves? How about show of hands of that? Anybody? Okay, we got two guys. Well, I really hope to see next time I train all of you, more hands go up because they have a really good electronics division there. We have one of the best valves on the market. 20 years ago, we built the valve, electronic valve, and now we're starting to see a real big movement on with electronic valves in the industry. So we have ProAx, another great service. I'll talk about it a bit. Rigid. How many people heard of Rigid before? Show of hands. Yeah, almost everybody. How many people know Emerson owned it? Oh no, two hands go up. So that's another division that we own. Incinkerator is another one. So that's food disposal. So if you ever went to, I think Home Depot, they may sell them. You go to Home Depot and grab it and you put it under your sink and you put all your food disposal in there to help the waste management companies. Thermostat and fuse type. Any questions on commercial residential solutions so far? No? Okay. Okay. So I just talked about our brands, our names, but here's some of the pictures of it. So this here is a screw, one of our Vilter screw packs. So this is the screw compressor up here, and here's the whole package. You got a Vision 2020 on there, microprocessor that controls the whole package. Today we're going to talk about Copeland compressors. We're going to get in depth and inside these compressors. I'm actually going to have people here, whoever's going to volunteer later, to do the teardown for everybody, and I'll walk everybody through that. This is one Dixel control. Dixel just came out with a super cool controller that looks similar like this, but it's a touch controller. So, you know, everybody's into the new and cool electronics, so it's a touch. So you just swipe it just like your cell phone, you know, and you can program it, set it up all through like a cool display, as well as they got Bluetooth. How many people knew the new Dixel, they have Bluetooth controllers? Well, one person. So they got an app where you install one of these controllers, you can log on to that controller, you can set it up from your phone. Just set it up. Instead of going down underneath the case, if it's underneath the case or whatnot, stand up and the contractor can just set it up like that. Some more controllers by Dixel. Like I said, they do case controllers, rack controllers. Anybody ever see this controller before? Yeah, what is it? Temperature, refrigeration temperature controller. One of the best on the markets. Multi-voltage. If you're not using a good refrigeration controller like this from White-Rodgers, you should look into it. This might be something really good for your customers. So you used it before? Mm-hmm. What do you think? What do you think of them?
We used them on a like chill water fan coil
and
stuff.
Were they difficult to set up?
No.
No. Super straightforward.
The relay, the voltage stuff is nice. Being able to have 277, 120, whatever you...
Yeah, the multi-voltage. Yeah, exactly. So super cool. I could spend so much time talking about all these, but we've got to get through some of this. Site supervisor. Anybody here a site supervisor? No, it's a new controller from our CPC line out of Kennesaw. It's similar to the E2, but this is web-based now. So we just did a rollout with one customer with over 1,000 stores, and they put one of these in each of their stores. And now they can remotely look in, like a contractor, go in and see everything that's happened. When the compressor's running, that superheat valve, how is it maintaining superheat? It can connect to our X-line unit that I'll talk about in a second. And if you get any alarms, it's going to send an alarm right to your cell phone. Right? This is under our ProAct division, so you can log right in from your cell phone or from your computer. There's value in that because you can see what has happened to that system when you weren't there. Most of the time, if you're working on a mechanical system, and I worked on tons, you go out and you get into a thing and you don't know what happened overnight, right? And we'll talk about that over thing. That's a very good platform. This is a rack controller, a building facility controller. Mostly, you'll see them mostly on supermarket racks. This is an Alco control. This is called our EXD-SH2 controller. It can control 2 electronic valves. That's pretty cool. And when you guys start using more electronic valves, I think you should start looking into the Emerson electronic valves. They got a wide range. They do from 10% to 100%, right? So a massive range. Our largest EX8 valve, depending on the refrigerant, can do up to 250 tons with one valve. So cool. Sensi. So Sensi thermostat, it's a Wi-Fi thermostat. You guys might have heard that. That's out of the Sensi division. So once again, right now I can check out my phone and turn the cooling up or down at my house. Super cool. Couple devices from our Cargo Solutions team. These here, if you have customers that ship product across the world or across the country, you should start doing them a favor and look into these Cargo Solutions. So this is called a tracker, a Go tracker. So what shippers can do is take this tracker and put it on their container ship, we'll say, or their transport truck on the West Coast. They get off the ship on the West Coast. So they put it in the container ship and it drives across the country. So that shipper can watch the temperature and where it's tracking across the country. So when it gets to the receiver bay and they pull out all the product and the receiver say, oh, this is all bad product, the shipper can be like, well, right here it shows me it was 78 the whole way and that's what the maintained temperature was supposed to be, right? Or 55 or frozen foods, right? So that protects the customer. The other one here, this one's a wireless Go tracker. So this tracker here, they can put it on a pallet, we'll say, for an example, of their goods that they receive or they're shipping as well. And so when it gets to the location, you can scan it with their phone and see the temperature. Did it alarm at all? Right? So then they can take corrective actions, right? If they're on the road with the tracking one and all of a sudden the refrigeration stopped, they can stop in that town and get a refrigeration mechanic to come and take a look at it so the food doesn't spoil. Pretty cool stuff. We recently just bought a company called Cooper Atkins. How many people heard of Cooper Atkins? Now, lots of hands go up, right? They have some cool stuff coming out. When I was a mechanic in the field, I used the temperature probes. Really good to check superheat or discharge air, return air temperature. But what they're releasing in April, and I thought I'd just throw this on the slide, really cool, is this little device right over here, these two little devices. So this is a little temperature probe. This temperature probe can either have a clip on it or you can put it right in a cooler. So if you have a customer that has 5 or 6 coolers and a 5 deck or some other glass doors, you could put this in there and now this is Bluetooth. This Bluetooth to this plug, that plug plugs into any wall socket. This wall socket now is Wi-Fi. That Wi-Fi can go now to a router and now anywhere that owner is or the contractor is, they can see the temperature of those boxes live and then get alarms. Super cool platform that they're coming out with and it'll be out in April. The new line of it. Lastly is the X-Line unit. This is our premium condensing unit. This unit here can do low condensing or floating head. Anybody know low condensing and floating head, what that is? One person will talk about it later today. It does up to 50 alarms. 50 alarms. So if you're off site and you get an alarm, you can go back and look at all the different alarms. Was it flood back? Was it low voltage? Was it, all these different alarms inside there. Over current. Has a really cool controller in there, a new advanced controller that actually will connect to one of these so you can remotely look into all your condensing units in your facility and see how they're running. As well, if you're using an electronic valve, you can connect them all together and you can see the superheat the whole time. You can see when somebody opens the door or leaves it open for too long and as that temperature rises up. Bunch of cool products. So I just wanted to show you some of that before I get started on the presentation. Anybody have any questions so far?
Are those products just for the food industry kind of?
They are for the food industry, but do you think you could, it's just a temperature probe, do you think you could put it somewhere else?
Yes.
Yeah, so that's what we market towards, but think about it. Think outside the box sometimes with some of these products. You can do different things with them. What you need to do is work with your rep and look at the technical specs. Is it going to be inside the technical specs? Because if it's outside, then it's not going to work, right? Same with any product. Any other questions? Okay, awesome. So the agenda for today, I have a lot of information to share with all of you. We're going to talk about mobile apps. We're going to kick it off with mobile apps today. Everyone get their phone out and we'll get started on downloading some apps. I'm going to talk about compressor construction. Very important. Talk about modulation methods. I think this is so important. If you do not understand or have not worked with modulating compressors yet, you're going to. It's the industry. It is happening, capacity control. If you want to get efficient, your system more efficient, you have to have some sort of modulation in your system. We're going to talk about causes and prevention of compressor failures. We'll go in depth on talking about why compressors fail, what to look for, and how to prevent that from happening. We'll do some system troubleshooting exercise. We'll talk about core sense. Anybody here core sense? Show of hands. Core sense, 1, 2, 3, 4. By the end of this day, you're going to know what core sense is, and you're going to go out to the field, and you're going to see them in the field, and you just didn't know that was a core sense device. How many people in here are mechanics? Show of hands. Okay, how many people in here are educators? Excellent. Okay, so we'll get started with the mobile app section. Okay. The 4 major mobile apps that you're going to need on your phone to help you as a technician in the field. The very first one's Copeland Mobile. How many people have Copeland Mobile? Show of hands. Oh, more than half the room. I love it. Application Engineering Bulletins. You need this app. How many people? Show of hands. Only a couple people have that. You need this app, and I'm going to talk about that today. HVAC Fault Finder. This is our Core Sense app. If you have any Core Sense in your Copeland compressors, you can use this app. But it's a diagnostics tool. So you can go in on the app, you're at your system and your system is not running. So you go on the app and you say, I do not have a compressor protector. Click on it, module. So you click on it, it says, does the compressor start? You click no. Does the compressor have voltage? Yes. Replace the compressor, or so on. It's a flow chart to help technicians in the field say, was it short cycling on the thermostat? Yes or no? Was it short cycle on the low pressure control? Yes or no? And it goes step by step by step to where you get to the end and it says replace the compressor. Don't replace the compressor. It's a system related issue. And that's a big thing because us as a compressor manufacturer, we see numbers up to 30% of compressors not failed. They come back, they say they're failed, but there's nothing wrong with them. Right? And same with other compressor manufacturers as well. It's a high percentage of compressors coming back and there's nothing wrong with them. So I want to show you some tips today to not walk away from that compressor and just say, oh, the compressor's failed. You need to know why that compressor failed, because if you don't know why that compressor failed, it's going to fail again. Does that make sense?
It does.
Excellent. So the other app, White-Rodgers Mobile, this is where you can find and size TX valves. So how many people know about the new refrigerant regulations that happened in North America January 1st? Only a couple people. I'm not going to go into too much of detail, but going forward on new applications, depending on what state you are in the US, but all across Canada, you can't use high global warming refrigerants like 404A and 507. Okay? So if you go to White-Rodgers Mobile, we have valves for the refrigerants like 448, 449, 413, 450. How many people heard of all those refrigerants? Show of hands. A few people. You're going to start hearing more and more about these new refrigerants because that's the way the industry is going. Okay? Other apps we have Sensi Protect, Emerson ProAct, Emerson Connect, that's the Dixel Bluetooth. The Go Reader, that's the one I talked about. You put the sensor on in the product and it ships and you can see it off your app. We got Emerson Canada White-Rodgers training, so if you ever you want thermostat training, gas valve training, you can go there. HVAC Check and Charge, this is actually our most popular app. So it'll actually do your superheat, subcooling, wet bulb, and it'll tell you if you need to add more charge or remove charge from your system. And then we have the Sensi app that connects with thermostat. Okay, Copeland Mobile. Everyone I'm hoping is downloading it or has downloaded. There are some cards on the side of the table if you need to download it. Just to make sure you download the right one. Go ahead.
If you're having trouble downloading it or any difficulty at all, raise your hand and I'll come back while Trevor's speaking and help you download it. So just raise your hand if you're having a difficulty doing that, and I'll see if I can get you going a little quicker.
They look pretty good.
Yeah.
So what Copeland Mobile is a database with all our compressor information. Thousands and thousands of compressors. Copeland has built a lot of compressors, right? And all this information is in here. And how does that value a technician? Well, this values a technician because you can go up and you can scan that serial number on that compressor. And it'll tell you what year that compressor was made. It'll tell you what the electrics are for that compressor. You can get in there, and I'm going to show you some examples on how to diagnose that compressor through the app. Okay? So I'm going to do an example right here. So the first thing I want everyone to do is type in this model number, and I'm going to do a live test as well. So I want everyone to follow along with me. So it's a 6DP35METSK. So, and don't go anywhere, don't select anything yet, because I want to show you guys step by step on what to do. And I want you to follow along with me. Okay. So, see, I have 6DP3R35METSK. But when you open it up, look how many options you have. And those of you online, do the same thing. Look at all the different options. So we start up here. This says 200 volts, 3-phase, 50 hertz. Well, we're not 50 hertz right here. North America, we have some 50 hertz in certain areas, but it's 60 hertz across our continent, right? So we don't want to do that. We want to go down and find a compressor. So I want you guys to all go down. And as you see, as we're going down, you'll see a bunch of different refrigerants. 407C, 407A, R22. As we go down, I want to pick a medium temp compressor. So let's go down to the 404A. Right here. Medium temp, 404A, 230, 3-phase, 60 hertz. Everybody see that? Everybody there? I want you to click on that one.
Trevor,
yep.
Trevor, excuse me if you don't mind. I think that the 6DP3R is missing in your written model number.
Oh, I am sorry.
Yeah.
That's my bad. There's an R missing.
And an 8 and a 3. 3R, 3.
Oh, and a 3. I am sorry. Yeah, it's on the paper in front of you. Sorry about that. So 6DP3R35METSK. So when you find the 404, medium temp, low condensing, 230, 3-phase, 60 hertz. So you just click on that one.
230, 3-phase, 60 hertz?
That's correct. So 6DP3R35METSK. So now we're in this compressor with 404. So you click on the first thing you want to do is click on mechanical. Sorry. It gives all the mechanical information. As you can see, here are the overall dimensions, the suction size, the discharge size, sweat, rotolock. So it tells you if you're going to sweat it in or it's a rotolock. Type of oil, polyester oil, right? Service oil, oil charge, and oil recharge. What do you think oil charge and the difference is in oil recharge? Can anyone tell me?
10 ounces may be left in the system.
Attaboy, exactly. So this is an OEM compressor, new compressor. This is a service compressor. So how many people know much about bill of materials on compressors? Show of hands. Not many, right? How many people write the full model number out when they're going to go into a Copeland authorized wholesale and have that full model number? Show of hands. Better start putting your hands up because those last 3 numbers mean a lot of stuff. So I can tell if that's a new compressor, if it's a service compressor. I can tell depending on the model of compressor what parts are in that. Does it have electrics? What type of feet? Are they hard feet, soft feet? Very important to have that bill of materials for your distributors. Because the guys that are promoting and stocking our product, they need those 3 numbers. So make sure you write the bill of materials down because that's going to help you get the right parts for that compressor. Okay, we get the weight That's very important. Now as a contractor, if I have to do a replacement, I know I need extra equipment, right? So now if this is on the roof, I might need a crane. I need a couple of guys now, compared to if it's a 25-pound scroll compressor, right? So now there's more advantage to it already. This is just one screen. So we'll go back. So if everyone press previous, we'll go to electrical. So I got some questions on here that everybody online sees. Let's just go back. What year was this compressor made? So it's an 18A. Can anybody tell me if the compressor is an 18A, the first three of a serial number, what year that was made and what month? Does anybody know here? And how do you tell?
Should I guess?
You can try.
Absolutely.
January of 18?
There you go. So now if you're looking for warranty, it kind of gives you an idea if it's in warranty or not. Once again, you got to go to your distributor, bring that model number and serial number and say, are we in warranty or not? So I just want to get back to 404 here.
January 18, by the way. That 18 is the year, and that third character is the month.
Exactly. Sorry about this.
B, C, D until
Absolutely.
the 12th.
This is also on a desktop version, if that ever comes into play for you.
So where you would go to find that, you would go to nomenclature and serial number. So you click on serial number, you could enter the serial number here and scan. It'll tell you where that compressor was made. Copeland made that compressor. Okay, so everyone go back. Next question, we know what the voltage is. So what were the two voltages that you guys seen before we picked the 230 volt one? 460, 230, dual volt compressor. Next we get into electricals. So the next question I had, what is the RLA MCC over 1.56 used for? So RLA MCC 1.56. What does RLA stand for? Rated load amps. Okay? Rated load amps. Okay? If I just press on this little eye here, it's used for breaker and wire selection. So if you're a contractor, you own your own business, and you're sizing equipment, or maybe you're potentially running into an issue, you need to check your wire and your breaker size. Okay. Next question I had. What type of oil? So we've seen that POE, as well as what was the oil charge. We talked about that. What's the weight of compressor? We know that. So the next question is, what's the performance rating? Let's go back to performance rating. So you press back, everyone click on performance. See everyone there's a rated performance? Is everybody here? Yeah? So at these conditions, this is what this compressor will do. 36,000 BTUs with 404A. Okay? These are the conditions. Evap 20, condensing 120, right? Amps 47.8 amps. So if you go down to dynamic performance, everyone click on dynamic performance.
Trevor,
Yeah.
you have a different number than I do, and he has a different number than all of us.
Maybe I clicked on the wrong 404. Sorry about that. Let me just double check. Oh, I picked the air conditioning 404. That's why. Sorry about that. Right here. Performance.
So we're supposed to pick the refrigeration or medium temp, low temp?
Medium temp, low condensing.
Oh yeah, see, I was on the wrong one.
Oh, okay. See, so if you pick the wrong one, you might get different conditions, especially if you pick the wrong refrigerants. How many people see this? Show of hands. You got that? You got that? Okay. So I'll go back up. Get the idea.
How do you switch to medium temp?
You got to go all the way back to this screen here.
Everybody go back to this screen here. I'm going to back up.
Yep. Go right back to this screen where you get all the results. Because this is really important.
It's a bit of ways down.
Yeah.
Yes, you go all the way down, way down. See how many compressor? That's why it's very important to understand this. Because if you select the wrong compressor, you might get the wrong information.
And if I may.
Yeah, go ahead.
So just to give you a heads up, because we do this all the time, if you're new to it, you might only have one option. You might only have two options. This is kind of rare to have that many, so don't let it overwhelm you. You're basically just picking out the refrigerant, what condition, what application it's in, and the electricity, the voltage, okay? But this one will take some time because you have a lot of options, obviously, so you got to be careful.
Yeah, maybe I should have picked one with less options.
That's okay.
Right?
Is it the 230 three-phase?
Which one?
60,
Yep.
Low tech?
Medium.
Temp? 404.
Medium temp, 230, you said, Trevor?
Right here.
Sure, it says 404.
Right, right at 404.
Right here, gang.
230.
You're doing 60?
Right here.
Right here. Medium temp, refrigerant's 404A, electrical's 230, three-phase, and it says 60 hertz.
How's that? Now is it better?
Does anyone not have it?
Nope. It automatically
Same
split.
one now, but
Yes.
what you're gonna end up with.
Yes. Good question, by the way.
You had the same one. Made me go all the way through that. Okay, it's all good. But this is what you learn, right?
Hey,
This is exactly the things you need to do, because if you do make a mistake and you pick the wrong refrigerant, we'll say, you're going to get different numbers, and that's really important. So, if you go down to dynamic performance here, you know you can change things. So what I want to do is I want to change the evap temp to 25. 25. And then I want to change the condensing. Well, I'll leave it at 120. Just go down and press calculate. And now these are the new conditions. 263 and amps, 98.8 amps, right? So now you can put your gauges on that system. You put this information in there and see if this compressor is working efficiently or effectively. And this is the amount of BTUs you should be getting out of that. If you all of a sudden get a way higher amps, what could that be? Just say it's supposed to be 98 and you're getting 110 or 105. High load. Plug condenser, who knows what it could be? It could be one of the many things, but it should make you think as a technician, well, this is what it should be. Okay? So, I just want to show you this. This is 263 and 98 at 25 and 120 condensing, right? If I just go back up here and I change this 120 to 80, changing the compression ratio, press calculate. Now look at this compressor. 384,000 BTUs this compressor can do now at the different design conditions. And look at the amps, only 78 amps. So I'm getting more capacity using less work, doing less work, 78 amps. That's something to really think about, especially when you're doing optimization projects. Is everybody okay with that right now? Dick? I'm going to get to that, Dick, and I'm going to show you the examples to do. Yep. Yep. Oh, great point. Look at the discharge temperature. It tells you. So you get your temperature probe, you put it on the discharge line. Where does it go in a semi-hermetic? Where do you put your temperature probe at? 6 inches away from the compressor. So it should be pretty close to this.
How close, plus or minus?
I don't know that answer, I'm sorry. But I'll look into that. There will be a plus or minus, but it'll be close to that. Because I've tested this. 10%. So within 10%. But very important to understand, we're trying to give you the tools to be better at your job. Okay, let's go back. Next question was, what part number for a crankcase heater? So you go down to service parts, click on service parts, and then here's all the parts that this compressor can use. So you go into crankcase heater, and here's the different crankcase heaters. Here's the part numbers. So now you have the part number, you can call up your Copeland authorized wholesaler and say, listen, Tim, I need this part number. I need 918-002801. They'll be able to say, I have one in stock, why don't you come down and grab it? So all the different service parts. Refrigerants used, so as we've seen there, you got to go back to that main screen. If we go right back here, so R22, 407A, as you go down 407C, 507, tons of different refrigerants. Yes?
Just one thing, I just tried clicking on the link. If you click on the link, it'll give you the whole, like, where you can buy it from.
Oh yeah, I'm going to get there.
Oh, okay.
Yeah. That's awesome. So, I love it, getting ahead of yourself. You like this. So, next question I had, cross-reference. So you click on cross-reference. And all of a sudden, this is the model that just say has failed in the field. You know it's failed from an issue. This is the part number, right? The model number of the new compressor. So you just click on the model number, and it'll give you all the differences, right? These ones are the exact same compressor. Just see how the bill of material is different? This is a 100 bill of material. That's an OEM compressor. This is an 800 bill of material. This is a service compressor. You click on where to buy, find a wholesaler. Look at this, United Refrigeration, Baker, Tropic, Johnstone. Right? So now I can click on that and call them right away. This is my supplier, you know, and it gives you driving directions. So if you're working in a different city, right, because there's lots of contractors like, you know, you'll work in a different city, you don't know where all the suppliers are, you can find them through this app and get to a Copeland authorized wholesaler.
Show them in stock.
Oh, yeah, I should. Great job.
No, I just do this all the time.
Show in stock.
It turns up green if it comes in block. That means not only do they carry it, they have.
Look at these guys.
Yeah.
Superstars, all in stock. So now you can call them up and say, listen, Baker, do you have this on your shelf? Yeah, come on down, we'll get it for you. You know, shorten that up. Get your customer up and running quicker. That's what it's all about, getting your customer, satisfying your customer.
The reason the miles are so high is because carrier is the only thing that's right.
Okay, the next one. Application. So we know it's air conditioning and medium temp, low condensing. Find a wholesaler. The other one that I didn't put on the sheet is the diagnostics tool. So you're a mechanic, you're out in the field. You put your gauges on the compressor and the system's running. So what I'm going to do here is I'm going to put 25 and 120 discharge or condensing, sorry. This is PSI. So I'm going to say 67, 225. And you'll have to check your amps. So I'm going to just say 90 amps. Calculate. Should be 88.6. We're 1.6 difference. Normal operation. So that compressor's running efficiently. You know the valves inside that compressor are working fine. You don't have to do any sort of valve test we'll talk about later. I know through this that this compressor is running totally fine. Okay? So let's change this from 90 to 110. Just throwing numbers in here. It's 24.2 above. So if you go down to troubleshoot, over 20, shut the system down. I click on troubleshoot, high current possibility. So we try to help you out on things to check. So I've been in the field, working many hours, long shifts. Can't always think straight. So this is kind of give you a guide to check different possibilities it could be. Anything else you want to add, Don?
The only thing is just so you don't get confused, if this is like a 7 or an 8 or a 9, if it's within that 0 to 10 and you go to hit troubleshoot, it's not going to troubleshoot anything because it's telling you that's okay. All right? You have to be outside of 10.
Awesome. Questions? I could spend a long time talking about that stuff. It's a lot of fun. So here's some of the answers. So show the people online. So January 2018, the 2 different voltage, breaker wire selection, winding resistance. I didn't do the winding resistance, but in the electrical, everyone go to electrical. Go to electrical, swipe all the way to the bottom. And press winding resistance. And what does it say?
Number resistance, line to line, line to line.
So what does that mean? What's your name, sir?
Art.
Art. So what does that mean, line to line now? What do you got to do?
Check your
Not your voltage. That's okay.
your ohms.
Your ohms, right? So you pull off your wires and you put it, and it should be really close to 1.176. So at first I was like, oh, that can't be close. Oh, I checked so many compressors over the last couple of years, and they're pretty much bang on if they're a good compressor. So how valuable is that to you guys in the field, right? Yeah, it's 3-phase, right? So what type of oil? Question. Line to Y. It's the way the compressor's wound. So it's when you go to it, you'll get 0.087. So that's the compressor.
I think you might be imagining only 3, but those have like what, 6, 9?
They got 9 terminals on it.
Yeah, they got a lot of terminals.
Yeah. So when you go across it, well, all you have to do is pull the wires off and then it'll be fine, because you should have the terminal plates on there, or terminal strips, depending if it's a 230 or a 460, depending on how it's wired up. Does that help?
I think so, yeah.
You think so? We'll talk about it after, and we'll get you. I'll try to clear everything up, and if I don't know the answers, we'll look and try to find the answers for you. Okay? The weight of the compressor. So I want to do this one. So 236, 8.4, 98 amps. We all seen that, right? You guys seen that? Then this is when we change it from 120 to 80. The capacity difference, the amperage, the EER. I did the next one down below is if you're using N40 R448A, which is a Honeywell refrigerant, or XP40 R449A, which is a Chemours refrigerant, and see the difference. 80 and 125 and 80. So look at the capacity difference in the same compressor with a different refrigerant, just to show you if you're using different refrigerants, you're going to have different capacities. And look at the discharge temperature. Very important to understand that stuff, because when you're doing a refrigerant retrofit, this is something that you really need to think about, because if you change the gas, all of a sudden, I've seen it where contractors wasn't meeting capacity because they did that refrigerant change. So you got to think about that stuff. Craig case heater part number, all the different refrigerants, the replacement model number, and if it's medium temp or air conditioning. And then we said the wholesalers. Any questions on that? I want you guys to play around with that. It's an important tool that you'll use in the field. And after we show contractors all the time, they're like, I use this app all the time now. Okay? Wholesalers use it. Next app we're going to talk about is AE Bulletins. So AE Bulletins, this is where we've put all the information on Copeland compressors and Copeland products. So over 30 years of data. And what we've done is made this easy and accessible to all of you. How many people heard of application engineering bulletins? Show of hands. If you're troubleshooting compressors and you're in the field and you don't have that information, how can you troubleshoot something if you don't know how it's supposed to work? You need this app, because this is how we design compressors. We use this and we give it to you to say, you cannot go outside these parameters or that compressor is going to fail. This is how you set up that low pressure control. You need a discharge check valve in the discharge line if you're using this much refrigerant, or if in this application. Okay? How the app works. Notification. So we update this all the time, so you have the latest and greatest. We have sections, refrigerants, facts and questions, history. So you click on sections here. So you got all the compressors, condensers, electronics, all the information that we build to give you guys to help you install our equipment, as well as service our equipment. So we pick on compressors. We pick on one 7 to 15 ton ZR, or ZR in Canada, KC, and ZP or ZP.KC, Copeland scroll compressors. So I'm going to talk about all the different Copeland scrolls that we have, but you need to make sure if it's in this range, 7 to 15 ton, these compressors, you click on that one. Because if you click on the wrong one, you won't have the right information. What's cool about it, here's the AE Bulletin. It gives you in-depth knowledge on compressors. These are compressor manuals. I didn't know there was compressor manuals. I worked in the field for 10 years, and I did look through my books, and I did find a few of these that my teacher showed me over the years, but I totally forgot about them. I learned about it in school, but I wasn't implementing it in the field. I would just use the manuals that come in the box. Yes, the manuals will help you, they'll guide you, but this here is the actual guide, the actual instructions for it. Okay? This button right up here is you can text it. So if you're a service manager out there and one of your mechanics calls you up and says, listen, I don't know how the demand cooling works. You can search demand cooling module and you can press send. And so you can text it or email it right off your app to your guys to help your technicians out, or your fellow contractor, your coworkers. You can do a search function, digital scroll. It'll give you every AE bulletin that talks about digital scrolls. So you find the right manual for that compressor that you're working on. Okay, go ahead.
Just one thing. I didn't catch your name over there. So what he asked earlier about when he said, what does that Y mean? How that thing? So you can go in here, think of this magnifying glass as Copeland Google, if you will. Okay, you can put a search word in there. You can put torque. It'll give you all the torque values. If you put search words in on what your question was on that electrical, it will actually give you a PDF step by step. You can blow this up. And like Trevor said, you can send it to somebody. Hey, I don't quite understand this. What are you doing? I'm just sitting here having a cigarette. What's up? Send it to your friend in the truck. Send it to your service manager. But just want to share that with you. That just put a couple words in there that what you're looking for. It'll pop up right there in step-by-step order.
Thank you, Don. That's excellent. Next tab down below here, refrigerants and oils, right? This is the #1 guide for Copeland. If you're installing Copeland, you need to understand what oil goes in it and what refrigerant's allowed in it that we approve. So you go to this refrigerant 9311. How many people heard of 9311 bulletin? How many people install Copeland compressor? Show of hands. That's good. I like the hands going up there. Well, you really should know what kind of refrigerant's allowed in our compressors. Okay, and what kind of oils? Go check that out. We get it all the time. Can we put this different oil in? Can I put this refrigerant? It hasn't been tested. Will it work? It might work, but you're not going to get warranty on that compressor.
So some you can, even though it's labeled 410A, all that on the compressor, it may have another, you may be able to put something else in it, is what you're saying.
Potentially. Well, 410As are ZP or ZP compressors only for 410, but some of our other models, like our ZF or ZF compressors, they will can do multiple refrigerants, right? So another one here, changeover guidelines. So if you're doing a retrofit from R22 to 407C, for an example, here's a step-by-step guide that we recommend you follow these procedures. As a mechanic, do your job right. And then once again, you can send that to your coworkers or to your employees.
I have a quick question while you're on the topic of refrigerants. Do you guys make a CR compressor that can run 410A? Reciprocating?
I know. I don't have that answer, but where do you think you could find that out?
I haven't seen one in the app, but probably look for it there.
Right there. Right there. Check that out. Okay. Facts and question page. This one's really important, like Don just talked about. This facts and questions, you can go in here and write superheat. It'll tell you what superheat is. Evaporator superheat, system superheat. Is there any other ways to, for example, find out if the compressor is flooding back or have liquid dilution? Yes, look it up. It's super cool. Demand cooling or liquid injection or EVI, enhanced vapor injection. You don't understand that stuff? Press it here. Find it. Over 3,500 questions from contractors just like you. We've built a database for you guys to do research. So when you're stuck in the field and you don't know how something works, just search it to help you out, to get that job up and running quicker, to make sure you're confident too as well. So this is an example, scrolls, troubleshooting, search, digital scroll again. Can I mount the solenoid valve used on the digital scroll compressor horizontally? Go in there and check what it says. Everybody okay with that? Any questions? Okay. Yeah, go ahead.
So, like Trevor said, those are, before we went digital, the world went digital. These are cabinets full of files that our tech support has taken these questions from you. Frequently asked questions, FAQ. Okay, so they just stockpiled it, and it's at your fingertips, whether it's Saturday night or Sunday. The other thing I want to touch on, and I know we're limited on time, and Trevor's condensed this, is on that Copeland Mobile, if you're ever working on one of our competitors' compressors, and you've diagnosed it as being bad already, put the first 4 characters of Tecumseh, Bitzer, whoever. It'll pop up their model and show you the Copeland compressor, and also give you the side-by-side view of what's going to change there. Okay, so you can get you can put the competitor compressor in the Copeland Mobile also.
Exactly.
And it'll pop up and it'll show you what the conversion is over to Copeland Mobile and side-by-side.
Yeah, exactly. That's a great point. And what you have to do there is, once again, work with your Copeland authorized wholesaler, and they can print you off the drawings. So, because maybe they don't fit the same, but the capacity is the same, or maybe they are a direct fit. So you have to look into that. Do a little bit of research, right? You always want to get your customer up and running. If you got a failed compressor, you could be talking about thousands and thousands of dollars of product, right? Very important. Thank you very much, Don. Okay. Any questions on the mobile apps? I know I spend a lot of time on it, and I fumbled it a little bit. We're good? Okay, compressor construction.
Do you know any way of tracking how many techs are out there using these now?
Yep. So we're about, I think, Yeah, so I think we're up to 50,000. Yeah, I think it's around 50,000. I'll have to double check. Every month I get a report on how many across North America are using the app.
I've actually gotten phone calls from the IT that developed these before and asked, they saw a spike in them and was asking me if we were training during that time but yeah, about every quarter I think we get how many downloads, and like Trevor said, what is that? Check and Charge is the most popular downloaded one. They track all that.
Yeah. So we'll get into compressor construction. What's this compressor here? What type of compressor, Copeland? Semi-hermetic. What's this one? Reciprocating hermetic. And this one here? Scroll. Okay? You guys are super smart. So, Copeland compressors. Okay? You can service them. You can take them apart. There's a few different types of cooling. What are the 3 methods of cooling? Refrigerant, air, and water cooled. Okay? Field repair possible, valve plates, oil pumps, depending on the model. Let's get into it. So, crankshaft, rods, piston, suction valve plates, discharge valve, heads, oil cup and flinger, depending on the model. And you'll find all this information out in that model number of the compressor. You go to Copeland Mobile and it'll tell you this stuff. Tell you what's in there. Is it a pump model or is it a flinger model? Okay? How does a semi-hermetic compressor work? Does anybody know? Can anybody explain it? It's up here on the screen. Go ahead.
I'll give it a shot. I mean, it's similar to a car engine in the way that it just has a piston that comes down,
Yep.
sucks refrigerant in, compresses it, and goes out the discharge port.
Exactly. So that's exactly. So as compressor starts up, it pulls down. As the pressure starts to drop, it opens up, pulls it down, opens your suction, and then as it starts to go up, it starts to compress that refrigerant as it goes through the cycle, right? As it starts to compress, closes the suction valve, and then opens the discharge and pushes it out. And it just continuously do that, continual compression. One thing I want to notice, and you can see a little arrow right here is something called the volumetric efficiency loss on our reed compressor. How many people still replace reed compressor, Copeland 3D, 40, and 60 reeds? Okay, few of you. Okay, so I'm going to talk about the difference between our reed compressor and our Discus compressor in a few minutes. This is a reed valve plate. You have our discharge on this side, high pressure, hot. We got our suction on this side. Does that make sense? How many seen a valve plate like this before? Show of hands. Lots of people, awesome. Okay. Air-cooled compressor. What's one thing you can do, and when just looking at the Copeland compressor, if it's an air-cooled, K-body will say, how can you tell it's air-cooled? What's the first thing you're going to notice? Okay, could have a fan on it, but that doesn't necessarily mean it's an air-cooled compressor. Well, it's an air-cooled compressor, but that's good. Nope. It's actually where the suction and discharge ports are. So if you see them right on the head, you could say that's an air-cooled compressor. Okay, just a quick way to look at it. If it's on the end bell or the Sater, what's that type of cooling? Refrigerant cooled. Okay, excellent. Air-cooled compressor. Air must pass over the body. So you have that condensing fan blowing air over the body, cooling it down. Because if you don't have that cooling, that compressor is going to what? It's going to start running hot and then overheat. So then there's water-cooled compressors. All it is some a copper coil wrapped around it, and you're using water to cool that compressor. Okay? Is there any difference between these two compressors? If you go to your wholesaler, Copeland authorized wholesaler, and ask for, I'm looking for a water-cooled compressor, because you give them a water-cooled model number, because there's a W in it, and they say, no, we only have an air-cooled. Could you put that air-cooled in its place? Yep. Yes, you can. Right? You just need to wrap some copper around it. They'll help you with that. Flinger feed. So there's two types of oil feeds in this style of compressor or case. You have flinger. So it's actually something that's mounted onto the crankshaft, and it spins as it hits the oil splashes up into this cup and lubricates the bearings. Okay? We moved on to an oil pump version. As you can see here is when we got into the higher pressure refrigerants like HFC refrigerant. We were having a lot of failures at the bearing right here. So we developed with an oil pump. And now what this oil pump does, it will pull up the oil and then lubricate all the bearings, right? Positive displacement. One thing that you don't see on these compressors is an oil pressure switch, because the oil pressure is below the cutout. Right, so the oil safety switch. Okay?
So what happens if there's a problem with the pump?
Well, then you're going to run into an issue with the compressor, but you won't have an oil safety switch on it. So you'll have to pull it apart and find out if it's an oil problem.
So you would only know after the fact, like your compressor seized.
Yeah, you can't put a, like I said, there's cutout switch not on these smaller ones. What I've seen a lot, I've seen this many times because I've done tons of teardown with some of the best compressor inspectors in the world for sure. And I've seen them come back where the guys pull off the oil pump and yank on it, snap this little tube right here, and said, oh, came from Copeland like that, ran for 6 months, but now all of a sudden the tube broke off. Well, no, we know that you pulled on it and snapped it, right? So just be aware of that. You might have to turn the pump and pull it out, or you might have to pull the bottom off. Best way is to pull the bottom off to take a look at it. If you break it, is a compressor going to run 6 months with no oil? No, what's going to happen? It's going to seize, exactly. So refrigerant cooled compressors, we talked about this already. You got that refrigerant cooling action, that suction coming over that compressor, keeping it cool, right? Same as our scroll compressors. You got that suction gas coming back, cooling the scrolls as well, the refrigerant cooled. Right? So what happens if I have really high return gas temperatures?
Discharge temp goes up, your oil gets cooked.
There you go. Hang on. Your discharge temperature goes up. Your suction goes up, temperature, your discharge temperature is going up. That makes sense to everybody? Excellent. Discus compressors. So we have so many different compressors, but our 2, 3, 4, 6, and 8D compressors. Same thing, they're semi-hermetic. You can take them apart, you can look inside. Look inside these compressors. If these compressors fail or if they run into issues, take them apart. We want you to look at them. We want you to find the problem, because if you find the problem, the next one you install, you won't have to replace it after 6 months. That's one of the biggest things that we notice as a manufacturer. The OEM compressors a lot of times last a lot longer when they're set up and installed properly. We see a lot of times when the service replacement goes in, it's a few months later that that one's coming back out and another one's going in. Okay, Discus compressor. So this technology is not new. We developed the Discus technology in the 80s. So the traditional Reed Copeland compressor will not allow of the discharge gas to exit. Not allow all the discharge gas to exit. Like I showed you where that volumetric efficiency loss is, right? So that's re-expansion of gas. So as that piston pulls down again, it has to force that discharge open a little bit to pull the gas out, right? So you're fighting. With the Discus, there's virtually zero re-expansion of the gas. See right here? So compressor cylinder head is under discharge pressure. So you got to remember that as well. That whole head on the Discus is high pressure, hot gas. Everybody okay with that? Good. Thank you. This is how it works. This is your suction. As that piston comes down, it pulls down your suction on your suction stroke, pulls the valve open, and then when it compresses, it closes your suction valve here and pushes up the disc. Pushes that up and you discharge out. See how you notice there's virtually no volumetric efficiency loss. Okay? This is what it looks like. I'm not going to go too much time through it, but you got an oil pump on these ones, oil switches, disc valve plate. You got different types of modulation, so a module load or digital compressor or block suction. We'll talk about that a little bit. Pistons, motor, lots of stuff on there. If you're working on these and they fail, pull them apart. Take it back to your office and teach the apprentices. Get them to look inside it, right? All that we ask as a manufacturer is throw all the parts back in. We want you guys to learn. Throw them back in, take it to your distributor, or even go to a wholesaler. I deal with wholesalers all across Canada, and those guys are awesome. They'll say, come in, tear the compressor back in my back shop before we get rid of it. Let's find out together and work with them. You should build a good relationship with your wholesalers. These guys are out in the field for us working, trying to help you guys. Yes, then lots of times you get a guy that has lots of knowledge and then a lot of guys that are green, but that's no different than our industry. I see lots of mechanics that are super smart, and then I see lots of guys that are brand new to the industry that don't have that experience. You have to share knowledge. If you work with a wholesaler and you're always waiting for one guy because you know that guy's the smartest, do me a favor and go teach the newer guys something. Teach them about balanced port TX valve. Teach them about how a compressor is supposed to work and how it pumps, right? Don't criticize or complain on these guys because they don't have all the answers. They're new to the industry as well. And so it goes both ways. You teach them, they teach you over time. I challenge all of you to start teaching your wholesaler one thing a month. I bet you by the end of that year, they'll be able to start coming back and help teach you as well. It has to be a give relationship, okay? Very important. Discus valve plate. So this is one of the cool things about difference between our reed and our discus. They're higher efficient than our reed, right? In low and medium temp application, up to 15% higher EER than the reed design. So what value is that to your customer now? Energy savings, right? Right off the bat. So if you're an installer and a contractor that replaces like for like, you're not doing your end user a favor. Because there's lots of other ways and tricks, and I'm going to show you a tip here today on how to help your customer have a more efficient system by not doing too much work at all, by just selecting the right compressor. Okay? So, valve plate design reduces overheating compared to our reed design. Okay? And we got Teflon impregnate bearings. Just wanted to show you a few tips on this. Okay. Discus replacement guide. Anybody ever heard of a discus replacement guide? Your wholesalers in the US probably might not have heard of this yet. We built this in Canada for our distributors. So this is the only way, this document here, is to convert a reed compressor to a discus. So if you go on OPI, does anybody know what online product information is? Show of hands. Okay, one person does. It's more of a wholesaler distributor. Okay? Or Copeland Mobile, if you go on Copeland Mobile and search a reed 6D reed compressor, or sorry, not a 6R reed compressor, and you look for the cross-reference, it's going to spit out the reed replacement. It will not give you the discus model. So here's something you want to go back and teach your distributor. Say, I met Trevor Matthews from Emerson. He told me that there is a document that can replace discus compressors, gives you the replacement of reed compressors to discus. Okay? This is a very important document. And say, can you talk to the Emerson rep that you deal with and see if you can get me that document? Because you're going to do your customers a huge favor. And I'm going to show you exactly why. This is the replacement guide. So for 4 and 6D. So standard model, unloader model. What's the difference? Does anybody know? Standard model, unloader. One has an unloader. Excellent. 6D. Standard model, 1 bank unloader, 2 bank unloaders. So now you have 2 banks unloading. Does that make sense with everybody? Okay, so we have 6DA, 6DB, 4DA, 4DB, 4DH, and 4DJ. So this A would be the lowest capacity for this 4D model. This would be the highest capacity. Right, just to give you a little tip. So when you're looking at that model number, oh, I know that's a large capacity 4D compressor. Here's the example I want to show you. Okay, you're out in the field, you check out the compressor and it's a failed compressor. You have open windings. The compressor has to be replaced. Okay? This is the compressor model number right here. You gotta have a 6RH1 3500. Doesn't really matter what the voltage is right now. So that is what has failed. If we go back, look here, 6RH1 to me is no banks unloading. So it's a standard fixed 6D compressor. Okay? You could potentially, and these are obsolete models, but you could potentially, if you're a wholesaler or your Copeland authorized guy has it in stock, you could get this one, or this one, if they're in stock. Right? But if you work with your wholesaler and say, I work with a lot of 6D compressors, they could stock this discus model. This is 2 banks unloading. Can you install a 6D compressor that has 2 banks unloading in the no bank unloading compressor? Yes or no? Yeah? Sure. Of course you can. So now, instead of your wholesaler having 1, 2, 3, or a ton of different compressors in their stock, they potentially could just stock this one for you, right? Because we send them out with no unloaders on it. So you have to buy the unloading kits if you want to use unloading. So teach your distributor that. It's important. And it's going to help you save time to have it in stock when your customer needs it. Okay? The other thing I want to show you is this. So the 6RH1 3500 TSE fails. What is the replacement you would recommend? if you go to Copeland Mobile or OAPI, this is what you're going to get. A 6RP2 3500 TSE 800. But that's the reed replacement. If you want the Discus replacement and if you work with a lot of these compressors, you could talk to your wholesaler to stock this one. Because we stock it in Brantford to reduce our wholesaler stock, to help them out. Because it's a lot of money to have a lot of different compressors, and we have thousands of different compressors. So this is what I would tell them to stock. If you don't need to use the unloaders, don't use the unloaders. Does that make sense to everybody?
I'm new to the trade. Just what the no unloading and
So this one here, you can't use capacity control on it. Okay, and I'll talk about it in a few minutes. It'll come together when I get to some of the slides. Okay? So when running a 6RH1 3500, this is the one that failed. R22 at those conditions, 105 and 40. This is it. The capacity is 407,000 BTUs, 40.3 amps, and discharge is 196. Everybody see that? You can go in the Copeland Mobile and do this if you want, but I'm just doing it pretty quick. Now we change this, replace it to the Discus I just talked about. Now look at the capacity, 418,000 BTUs. So we got more capacity. Look at the amp draw now. No, so is there an efficiency gain there for your customer? Yeah, for sure. So not every reed compressor to a Discus is going to be a perfect swap one for one, right? You might have to change service valves on certain of them. Is it hard to change service valves? Show of hands. Can be, but not always. And we've designed them to almost be a direct fit on most of them. So once again, what you need to do is ask your wholesaler, can I see the drawings? Are these an exact match? And then if they have this in stock, you're doing a favor for your customer. You're running at lower discharge temperatures, right? More efficient. Does everybody kind of see where I'm going with this to help your customers out? Okay, excellent. Construction of the valve plate. So we have two different designs. So we got floating reed. Has anybody seen floating reed design when they pull off a head before? Okay, then we got delta reed. These ones here are riveted on, and it all depends on the model number. You can't switch these. So if it's a floating reed, you got to go with a floating reed plate on that compressor. If it's a delta reed, you got to go with the delta reed. That's why the model number is very important, having the right model number, because that's one of the biggest things by the distributors and wholesalers, that a lot of times they're not getting the right part number, so that would lead to potentially the wrong product. And you don't want to, say, for an example, have to wait a week to get a compressor and then it's the wrong one in DC, right? Some of the things inside them. We got a crankcase ventilator valve here. We got an oil check valve right down at the bottom. You see right here, that's an oil check valve, free floating. And then we got a internal pressure relief. So if that differential pressure gets too high, it's going to relieve. It'll make a loud sound, really loud. Okay? Inside the compressor. Does anybody know the purpose of this vent valve? Can anybody tell me?
Oil flow?
No, that would be this one down here. You're right about that one. Great job. So this one right in here. You'll see them in our 4 and 6D compressors.
Flooded starts, if you have some sort of a flooded start where you have rapid expansion of the liquid.
It does help a little bit with that, but the whole purpose of this is put pressure back into the body of the compressor. The crank should always be at a higher or lower pressure than the body. What do you guys think? This is very important to know. So on this side, should this be a lower pressure than back here where the end bell is? What should this be a lower pressure? Yes. Why? Oil flow, right? So this is always going to be back here. It's always going to be about 2 psi higher. So you make sure your oil flow. And I'm going to show you a few slides that's going to clear that up a bit. But I wanted to show you right now. Talk about it right now. Short and tall heads on the Discus. So OEMs, here, short head models typically OEM. If aftermarket replacement is a tall head, customer can swap the heads. So if you have a failed compressor, right, and you have short heads on it, and the service one comes with the tall heads and it doesn't fit, you can take these small heads and put it on there. Okay? It's a little tip. Deep sump and flat bottoms. So we have different models. You want to make sure, once again, you have that right model number. Because if all of a sudden you give them the wrong model number and you get a deep sump, it's not going to fit. You know, potentially it's not going to fit into where it's supposed to. Yes?
Is the reed and the discus, are they different short block also, or just from the heads up?
Well, right here, as you can see, the question, what was the question again? Is the reeds?
The reed and the discus, are they the same from the head down? Are they interchangeable? You put a discus head on a reed
No,
short block?
no, you can't. You can't change the discus to a reed. Is that what you mean?
Yeah, basically reed
Yep.
to the discus.
So this is a really good point. This compressor here, if you can see on the left-hand side, this is called our Discus 2 compressor. D2 we call it. See, there's 15 bolts on the top of the head of this compressor. See this compressor here, same 6D compressor. Do you see how there's only 9 bolts on that? This is a D3. You can't switch this. So over the last 5, 6, 7 years, we've been selling OEMs this type of compressor here called a D3, Discus 3. The replacement model you're going to get is this. And a lot of guys are like, no, I need the same compressor. Like I said, swapping like for like. What you need to understand, the feet on the D3 and the D2 are exactly the same. The suction and discharge are in the exact same location. The only thing you have to make sure of is how high that OEM built the frame. Shouldn't be a problem though. That's why one of the things is we just didn't have enough bodies. But now we're starting to get these into circulation. Yeah, go ahead.
Hey, I know there's some people that are just starting out. I know you mentioned your grain. Another quick way to walk up to a compressor and tell if it's a discus, the bolts on the head will only be on the outside of the head, okay? If it's a reed, the bolts will be inside on the head too, locked down. So.
Okay, and we'll probably see that today when one of you tear one down. I don't know what the models we have. I haven't checked, but. Reciprocating compressor. So this is the CR, these are our A, our Cs, and it'll be up here in a second. I don't remember off the top of my head. So these are hermetic compressors. You cannot service these ones, right? So if something fails, you can't pull them apart like a hermetic compressor. We have a discharge line through the oil, and what do you think we do that for? Why do we design it like that?
Oil flow, keeping oil in the bottom.
What was the question again?
Why would we put the discharge through the oil?
Be cool.
Not cool, opposite. Warm to heat the oil, and if any refrigerant in there, to boil any refrigerant off. We have different models, A, R, and C. As you can see, I got them all highlighted in bold, all the new refrigerants that these compressors can do. And then on the end, like low temp, extended medium, or high temp. You want to make sure if you're using low temp, you have the low temp compressor. You got to look in those AE bulletins that I talked about for that compressor to see if it's the right application. Because I've seen it many times where people would buy a compressor, they would go install it, and if they install a high temp compressor in a low temp application, do you think that compressor is going to run? Well, it's going to run for a little bit, right? Any questions on that? Okay, scroll compressors. How many people work on scroll compressors today? Every hand goes up. Because this is most of my classes that I do, everybody works on scrolls. We're almost at the 200 million mark for scrolls. Back in 2017, we sold our 150 million scroll. That was 3 years ago. And we're making, I think, a minimum of 12 million scrolls a year. So we're closing in on 200 million scrolls. So there's a lot out there. Okay? And the big thing here, we have 3 horsepower to 60 horsepower scroll compressors. And you want to see a 60 horsepower scroll compressor, you're not moving that by yourself. Okay? One thing that I want to show you right now, I'm going to talk about our platforms scrolls, because a lot of people say, oh, I know how a scroll works, and that's totally fair. Scrolls, if you know how the scroll works, they pump, they run, similar, like they all use scroll sets that we'll talk about in a minute. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's my AC. So I got 12 different AC scroll compressors. Okay? They all run on different refrigerants. They all have different internals the way they work. So I'll go to refrigeration. Another 1, 2, 3, 4, 5, 6, 7, 8 for medium temp. And then 1, 2, 3, 4, 5, 6 for low temp. That's over 20 different scrolls, different capacities. They work differently. Some have liquid injection, some don't. Some do high temp, some do low temp. It's important, yes, I know how a scroll works, but how does that scroll work? That's the important part. Does it have an internal pressure relief? You know, how is it protected? We'll talk about that stuff today. But we have a lot of different scrolls. You really need to go to those AE bulletins or application engineering bulletins and look it up. Understand how it's supposed to be installed, because one scroll installed in one application is installed differently in a different application. Does that make sense? Awesome. Okay. Some of the difference between scrolls and semi-hermetics, you realistically have two parts moving. You have on the top a fixed scroll and on the bottom an orbiting scroll. And I know Brian had a scroll set around here. I don't know where it's at right now. Could pass it around. But as you have an oscillating. Oh, sorry. Go ahead.
It scrolls right there around the corner.
The two sets? Yeah, pass it around, please. But this is just to show you got two really moving parts. And in a semi-hermetic, you have many different moving parts. Okay, a lot of different things that potentially could run into issues. How a scroll works. So a continuous pumping action. So as the scroll pockets work, so you got suction coming in, it squishes it up and starts to squish that gas and compress the gas until it goes at the top. The top's the discharge. So if you put your hand on a scroll, it's going to be hot. You're going to be like, that's pretty hot. Right? Depending on the application again. Thank you. Pass that around. That's great. So you have a fixed scroll set on the top and an orbiting one on the bottom. This is how it works. You got your suction gas coming in, cooling the motor. This is your stator. Here's your rotor. Here's your crankshaft. You got a main bearing right here, and then you got a drive bearing. You got an orbiting scroll right here and a fixed scroll, floating seal. This is an anti-rotation device right here. Right? So it doesn't spin backwards. Right? Then we got another different check valve, discharge check valve right here. But one thing I've seen, like if you look in the AE bulletin on this application, we have spring type, and then we have just floating disc type, floating type. So depending on our refrigeration compressors, they'll all have the spring type. Some of our AC will have a floating one. So if you look in the AE bulletin, depending on the application, you might have to add a discharge check valve. You'll only find that in the application engineering bulletin. So somebody could install the compressor, cut out the discharge check valve when they do, and then all of a sudden you're running, and then you lead to another failure potentially. Okay? And then you got an internal pressure relief right here, depending on the model of the compressor again. Remember, we have over 20 different models of compressor. Some of them have an internal pressure relief, some of them won't. Okay, we have axial and radial compliance. This is really to protect the compressor. That means the fixed scroll will separate by 1 mil, up and down, or they'll separate radially. Some of them have a spring in them, some of them won't, and it'll separate radially if you get oil up into there. These are called flanks. Right here, that's called flanks. That's what we call them. And they squish the gas together. But all of a sudden, if you get oil in here and it couldn't separate at all, you'll damage those. Right? Or liquid refrigerant, or debris, copper. Question?
I do have a question. So one thing I've heard a couple times now is that supposedly scrolls can take liquid, or that they're not necessarily as prone to dying as quickly as a hermetic or semi-hermetic.
Oh, yeah, so they're liquid tolerant. That's what lots of people say. We say it's liquid tolerant. Like I've got video that I'm going to show you in a minute here is going to say liquid tolerant. Okay, it's a little bit of scroll, liquid can go in it. Okay, but what does that liquid do to inside that scroll? What's inside the scroll set while it's running at all times? Oil, right? So in between, right here, right between this fixed and this orbiting scroll, you got oil. You got oil film in there to keep that seal in there while it's pumping. So now tell me what happens. What's refrigerant? It's a good what?
Solvent.
It's a good solvent, good cleaner, right? So what happens now? Oh, I can shoot up some liquid refrigerant in there. Okay, it passes and it's good. Now what happened? Washes oil off. So this is metal on metal. So we don't have any seals or anything like that. This is metal on metal, right? So then what happens when that refrigerant goes in there? You have metal on metal. And then what's that? Is that damage or not damage? That's damage. So yes, for sure, we can take it in and we won't break them and crack them and, and the compressor fails. But it'll wash that oil away and potentially damage that compressor.
Right. Okay.
Go ahead.
All I want to say is that's always brought up a lot. We don't want liquid refrigerant. It's not designed for that. In fact, what he's talking about, what Trevor's talking about here, this radial compliance, okay, that's what that does. When it senses a droplet of refrigerant, liquid refrigerant, or any kind of debris, it separates and kicks it out and flashes that refrigerant off. Yeah, so it's designed to prevent it from coming in is really what it's all about.
Yeah. So
It's
really, it's not a matter of it being tolerant. People should just stop saying it.
more tolerant than the semi-hermetics.
Oh, wait, yeah.
So that's what I would say, yeah.
Not to the point where it's like okay to leave.
So I got a video here that I'll show you right now. So right here you see this style has a little spring in it, right in the bushing. Other styles will have different radial compliance.
During periods of cool weather, refrigerant can condense in the gas lines of HVAC systems, eventually migrating into the compressor. A key feature of the Copeland scroll compressor is its ability to handle liquid refrigerant with its compliant scroll design. During normal operation, radial contact between the two scrolls is held tight by centrifugal force, acting outward upon the orbiting scroll. Axial contact is maintained through positive pressure differential between the stationary and orbiting scrolls. In the event liquid refrigerant enters the scroll cavity, the radial and axial compliance allows the scrolls to separate, safely passing the liquid out of the scroll cavity without damaging the compressor.
All right, so we're separating so we don't damage those flanks. But if you get a lot of liquid refrigerant in there and you wash that oil out, it's going to cause some damage. One of our key designs for our scrolls is something called a floating seal, optimized tip load. So the best way to show this is the floating seal prevents the compressor from drawing into a deep vacuum. That's really important. Should you run any compressor in a vacuum?
No.
What could happen? What's that?
I heard something about the windings burning up.
Yeah, you could get an arc inside there and it shorts out the windings, right? That's why you never power a compressor that's under a deep vac before you charge it up. But on this floating seal design, right along the top here is this metal little piece. This is called the muffler. So when the scroll compressors start unloaded, when it starts up, this pushes up against the muffler plate, which pushes down that fixed scroll. And inside the scroll set, there's a little hole right like this. That pressure, intermediate stage, pushes up on the bottom of that to mate those scroll sets as it pumps, right? So when you start to get a high compression rate, what is compression ratio? Can anyone tell me?
Your absolute suction to absolute head.
Yeah, exactly. So you divide them. So if you get over below 11 to 1, compressor's going to pump fine. If you get over 11 to 1, it's going to unload. See how the suction comes in up here? Here's the floating seal that's pushed right up against the muffler plate, and then you get discharge pressure there. That's pumping, fully pumping. But all of a sudden, you'll see the floating seal not up against the plate because it unbalances that floating seal to separate it. And we have devices sometimes to protect it. We separate them on purpose. Okay, so just remember that. Compression ratio is very important.
How many folks know how to do compression ratio? Just out of curiosity.
I think I measure quick. It does
Yeah.
it for you.
So real quick, why don't you explain that, Trevor? Or I'll do it real quick.
Yeah.
So basically, he had the right answer, but I don't want to. It looked like not everybody understood that, and that's cool. That's why we're here. But compression ratio is taking nothing more than taking the reading on your gauges and adding atmospheric pressure. So you got PSIG on your gauges, adding atmospheric pressure, which is 14.7 or standard atmospheric pressure. We rounded up to 15 for easy math. Okay, that changes it to absolute. We take the absolute suction then and divide it into the head pressure and absolute, and that is whatever that number is when you do the math. If it's 10, then it's 10 to 1. If it's 5, it's 5 to 1. Okay, normally air conditioning is 3 to 1. Medium is around 5 to 1. Those are just roughly, and low temperature would be somewhere around 10 to 1. So anyways, I just want to make
sure. Thank you very much, Don. Thank you. So Depending on the compressor, you'll have internal pressure relief or temperature operating disc or motor protectors. Internal pressure relief, I talked about it. So low pressure refrigerant, they'll relief at 375 to 450 differential. High pressure, like 410, be 550 to 625. That's the pressure differential to open that valve so it doesn't explode. For models with no IPR valve, an additional high pressure control is mandatory. Where would I find that information? Application engineering bulletins, great. Okay, so this is a temperature operating disc. So as the temperature or amps go up in some of our scroll models, you'll have a little disc in here that'll open, bypass discharge gas, and shoot that gas right on a motor protector to shut down that compressor. Okay? We have different types of motor protectors. One's like I just talked about, temperature and current. We also have one that's just on temperature, a thermistor inside the compressor. These are more on our larger compressors. Whereas the temperature starts to rise, we want to shut it down before it causes too much damage. Okay? How the scroll works? Well, we have a crankshaft like I talked about earlier. Down below in scrolls, it's going to be all oil. It should be all oil in there. You have a flinger oil feed. What happens here, it sucks the oil up and feeds all the bearings, right? To make sure that you have lubrication, which you need. Questions on that? Scroll design.
It may be out of subject, but as far as when you're replacing the R22 system, 410A, I've heard different stories on the RX11 deal. What are your thoughts about using that stuff to?
We don't recommend anything in our compressor. So once again, go back to 9311. I've used this stuff as a mechanic out in the field to clean out systems, right? But when you're going from R22 to 410, you really a brand new system. It's a totally different system, right? So you're talking about cleaning the line set, I guess, out?
Yeah.
Yeah, so we don't recommend using anything that can go into the compressor besides one thing called Spectro. Can't remember the name of it. You got to go back to 9311.
Spectronics are low.
Spectronics?
And if I may, so here's the deal, because we work a lot of times in wholesalers, and it would be awful hypocritical of us if they invite us in and we're doing a class and we're saying we don't agree with that and they're selling it at the counter. So here's how that 93-11 works, okay? We don't spend our money to test someone else's product because it takes millions and millions of dollars. It doesn't mean anything's bad, but it doesn't make that grade on that 9311 unless they spent their money. We tell them how high the bar's got to be. This is, you got to keep it in this envelope using your product under these conditions, and if it makes it that do that, and they give us the money to test that, then it makes the sheet. It's not really a pay to play, but you have to prove your product, okay? Doesn't mean it's bad. Like Trevor said, I would be a hypocrite if I said I've never used it. Use a lot of it, okay? But that's how it works, okay? Just so you know.
Okay, modulation methods. There's quite a few different ones. We're going to go through a few of them. We have two-stage modulation. We got variable speed. We got digital, and we got tandems and trios. So two-stage scrolls. Basically, we've developed a scroll compressor that can do 2 stages. So inside it, there's a solenoid inside that will bypass gas. So there's little bypass ports that will open up. So you can run compressors at 67 or 65%, depending on the compressor, to 100%. What kind of advantage of this could be in a residential home? What's the advantage of having multiple stages?
High load, low load.
High load, low load. What else? Better efficiency, humidity, right? Lots of good advantages, right? So here, this is how it works. You got bypass ports. They'll open and close. 100% when they're closed. When they're open, bypasses, 65 or 67%. Okay? It's all done on a solenoid inside the compressor. Down here, I got AE Bulletins. See, there's 3 different ones that talk about it. So sometimes there's multiple AE Bulletins talking about compressors. Very important to find those and understand those so you know how that compressor operates. That's it. Does everybody understand that video? Pretty straightforward, right? Easy technology to implement. Digital compressors. How many people worked on a digital compressor before? Show of hands. Couple, seen them. How does it, Thomas, did you just say you've worked on digital? How does a digital work? Do you know?
Not really.
That's okay. Anybody else?
With a solenoid?
It has a solenoid on it. So what it is mechanical modulation. So the way the digital works, remember we talked about axial compliance? So what it does, it'll separate, and it's all done on time, either 15 seconds or 20 seconds, depending on what type of compressor you're putting in, right? So if it's pumping for 10 seconds and unload it for 10 seconds on a 20-second cycle, what's your capacity? 50%, right? So 100,000 BTUs, or is the 100,000 BTUs compressor, pumps for 10 seconds, unloads for 10 seconds, is 50,000 BTUs.
And it sounds like it's going to detonate. You swear you got a bad compressor.
Do you?
AI likes to put them in there.
Yeah,
And you're
it depends. It depends on the size. If you work on smaller ones, and it's all right. One good point. Lots of people say, "Oh, they're louder." Well, we've done lots of tests, and you can look in our bulletins and how loud they are. And if you feel they're too loud, we sell sound blankets for them.
Oh, no, it's just first time you see
Oh, the first time everyone's like, "Oh, there's something wrong with the compressor."
cabinet open and you're like,
Yeah.
it sounds like
Yeah.
it's chewing rocks. And it keeps doing it like it's pumping down or something.
Yeah. So, and why it does that, I'm going to talk about that in a second to show you. I'll show you in a second here. So our ranges are 3D can go from 10% to 100% capacity. So you have 100,000 BTU compressor, 10,000 to 100,000 BTUs. We got our 4D models, 50 to 100, 6D, 33 to 100. So you'll have a block suction, you'll have a digital, and you'll have a fixed head. And then scrolls, some of them can go down to 10% to 100%.
The hermetics was the one I was talking about.
Yep. Okay, digital scrolls. We have two different designs, piston type and our larger one, intermediate type. So you'll have a pipe outside the compressor like that with a solenoid on it. This solenoid's on the side of the compressor. They're good for better load matching, wider range of capacity, reduced compressor cycling, better for humidity controlled, and applied on multiple evaporator systems. So that's some of the benefits of going with a digital. Right here, just showing how it loads and unloads on different types of cycles. So 4 seconds pumping, 16 seconds not pumping, 20% capacity. How you can tell if it's a digital compressor, and the third character on the scrolls, it'll have a D. Okay, that's how you tell if it's a digital. Really, when you look at it and you see a solenoid on the top or the side, you're going to know. This is how it works, the digital. So when you'll see this solenoid activate, all of a sudden it'll bypass discharge gas, separate the scroll set, so there's no pumping action. So what you're hearing is the flanks touching each other as it's still spinning. So one tip, if you go up to a compressor and it's a digital and you put your amp clamp on it and you're like, why is it making so much noise? And you put it on, and when it's loaded, it's going to be, we'll say an example, 15 amps. When it unloads, it's going to be 9 amps. So if it keeps doing that, you're going to know it's going to be a digital. A fixed compressor is not going to do that. So that's one tip on that. If you ever have a solenoid that's stuck open, so the compressor doesn't pump, but you got your gauge on, why is it not pumping? Check the solenoid. Maybe the solenoid's the issue, right? Pull the solenoid on, put it on magnet on, right? On and off, there could be dirt in it. And then if you're about to cut out the compressor, the last thing you should do is pinch the line here, right? Because if you're cutting the compressor out, you want to make sure, so if you pinch the line, there should be no bypass gas. If it loads back up, well, you know there's something wrong with your solenoid. If you pinch that line and it doesn't, there's some damage inside the compressor. Does that make sense? Okay. Yeah, go ahead.
No, you go ahead.
So this is our larger compressor. So it has a solenoid on the side. You can pull it off to see if any dirt gets caught in there. So if it's always unloaded, pull it apart. Any questions on the scroll? No?
If I may.
Yeah.
So I had trouble wrapping my head around the digital. I think all of us did as instructors when we first came in. So that's a Copeland term. So all he's really saying, as you just saw Trevor do a great job of explaining, is it's instead of turning the compressor off, which is a lot of energy, as we all know, the starting and stopping, it's just loading and unloading and using that solenoid, okay, by modulation. Okay, it's sending signals to it.
Thank you. Digital Discus works on the same principle. They have a solenoid on top of the 3D compressor, for example. When it's loaded up, you know, here unloader pistons allow suction gas to flow through. When the solenoid activates, it pushes down some pistons, it blocks the pistons, and so there's no work being done. And it's all done on time again too. Okay, this is one of the advantages, and we have a lot of contractors, and we do a lot of retrofits with customers. Here's a multiple compressor application, and you can see the suction jumping as a 6D turns on, a 4D turns on, whatever turns on, it jumps. The pressure goes up and then it goes down, right? So you have to have a good control, guys, to set up, say, a multiple compressor application when you have a lot of capacity control. So you'll see the bottom one here, the digital compressor. You'll see all the cycling. See all the cycling before. So we activate this digital, so you only need one digital or on that multiple compressor application. See how it's on all the time? Now look at the cycling of this rack, or these multiple compressor application. And now look how tight in that suction group. Now is that, what advantage is right there? How does that help your customer?
It saves on compression ratio.
Saves on compression ratio. What about, like, we went from this to this? Cycling, right? So less work on those compressors. Less work on those contactors. So it's very important to understand this technology. And look at this. Average suction pressure up 3 to 4 psi. A rule of thumb is one increase in suction, 1 psi increase in suction, you get approximately 2% efficiency gain. That's your compression ratio that Don talked about earlier. Reducing that compression ratio, less work, less heat. Everybody understand that? Excellent. One cool thing about the digital compressor, you can do retrofits. So you don't have to pull the compressor out. We've done tons of white papers where if there's a 20-year-old compressor, you find the worst compressor on the rack. So you use Copeland Mobile. Which one's running the hottest? Then you pull out and put a new compressor on without even activating a digital. You're going to get 4% efficiency gain because it's just more work done. Because you're going from a brand new compressor from an old compressor. But then you activate a digital on there, you can get, we see upwards to 12 to 15% savings, right? Depending on the application. So you could actually go to your wholesaler, talk to them, here's some part numbers, just say, listen, I have a multiple compressor application. I find that the capacity and the loading is not very good. We actually added a bunch of glass doors to 70 feet of 5 deck, right? Now all of a sudden that load is really low on that compressor system. So the compressor banging on, banging off. Well, potentially you can retrofit to a digital compressor. Same with the 4 and 6Ds. Once again, application engineering bulletins, read them. See if that's the right solution for your customer. Okay, some of the benefits, you can put them in any one of these applications. We see them in all these different types of application. Okay, so one of the things that we see doing the upgrade is up to 30% more efficient than hot gas bypass. Does anybody know what hot gas bypass is or can explain it? Go ahead.
It's basically just when, so this is not for the defrost, right? This is just for head pressure control?
Yeah, just so.
Yeah, so it's basically when you just bypass before the condenser.
So, well, yeah, you bypass, go into the evaporator, put the load on the evaporator, so that system keeps running. So what's that compressor right now? Is that fully loaded? So I'm putting fake load on that evaporator so it keeps running. Because if you're in an auditorium with 1,000 people, load's really high, you need that compressor to run. But everybody leaves, there's no body heat in that room anymore. Now that capacity dropped, right? So that compressor, what would happen to that system now if you didn't have some sort of capacity control? What would it do? No, it wouldn't flood back. It would short cycle, right? It'll turn on, turn off, turn on, turn off. So they used to use hot gas bypass, right? So now that compressor is fully loaded. A lot of energy usage. You go with the digital, right? Using the digital, it doesn't that compressor's not fully loaded all the time. It loads and unloads, loads and unloads. Okay? And this is kind of what your contactors could look like. You know, instead of all those cyclings happen, then you can reduce the amount of ons and off, right? So it helps, you know, that brings value to your customers because now you don't have to change the contactors yearly. You know, yes, okay, you want to make money, 100% do that. But you should have enough customers. You don't have to be just replacing parts. You don't have to be a parts changer. You could say, listen, if we go with this solution, right, we don't have to come in yearly and change the insides of that contactor, right? And then you can work on error because that building probably has a ton of things that need to be replaced. right? So that's value that you bring, value add to your customer. Different types of solutions, supermarket racks, walk-in freezer, commercial system. One thing about the digital compressors though, they're not for every application. They're not very efficient at part load. Okay? So you have to think about that. And what was your name?
Chris.
Chris mentioned that, oh, they're very loud. So if you take a digital compressor, you put it on a metal roof right above the boss's office, and it goes, he's not going to be too happy. So you have to think about where you're putting the digital compressor. Okay? So it's not for every application, but it can fit a lot of application. Discus capacity controls. I'm going to go through this a little bit. 4 and 60, we talked about it already. It's for capacity control. So the head will load and unload. Right? So the 4D, when you don't have the solenoid energized, you're at full capacity. When you energize that, you're at 50% capacity. Does that make sense? Okay. And this is normal operation, fully loaded, de-energized. When it valve energized, suction port closes. So that's how you're getting your capacity control. Okay. This is a really important slide if you work on semi-hermetics. The temperature probe, when you're looking at the pump, temperature probe always has to go into the left side. Once again, where would I find this picture?
Bulletin?
Application engineering bulletins. Block suction or digital discus will go on this side. 6D, same thing. You're looking at the pump side, the temperature probe goes in it, because this one's always running. This is your 33%. This one here could be a block suction optional or a digital or discus on the right side. Everybody follow me there? Okay. And then here's some of the part numbers, capacity control. So you want, once again, you want to make sure you bring the full model number to your distributor to get the right compressor. Can you do, once again, can you take a 6D non-unloader compressor and have it replaced with a unloaded, 2-bank unloaded compressor?
Yes.
Yes. Okay, perfect. It'll be a different model number, but exact same capacity. So I love this. I'm going to get to this section right here. I want to see a hands. Everybody here said they install and work on Copeland compressors. And I've trained hundreds and hundreds of mechanics across Canada. Okay? Show me a hands. Does everybody here think, or do they know, can I just take a variable speed drive and put it on a discus compressor and it'll work? Show of hands that say you can. Right now on one of your systems, okay, how about, let's talk about like this. Say you have a scroll. One of your customers have a bunch of scrolls on there, larger scroll systems. Can I right now go to my distributor, buy a VFD and go put it on that scroll? Yes or no? Say, show of hands of yes. Or, so none of you. So everyone thinks no. Or say everyone doesn't, no one wants to share.
It's going to last.
I think no. I don't know.
Don't know. Yes, any fixed discus compressor or scroll can have a drive put on it in the field right now. Fixed compressor. Okay, right here. Fixed compressors with variable speed drive offer a wide range capacity. That's fixed, so anything in the field right now. So, depending on the model, again, remember I talked about going to those AE bulletins, you can go from 35 to 75 hertz, depending on the model. So that's down to 46%. That's a lot of capacity.
3-phase only.
On 3-phase?
3-phase only, right? Yeah.
These ones are all 3-phase. I don't know that answer. I'll have to double check. I think so, but I don't know the answer.
I think it's 3-phase only.
I think he's right.
Well, we have single phase variable speed, but maybe not on our fixed. So,
I'm not sure.
yeah. So here, look, 3D, 40, and 60. They can operate 45 to 60 hertz. So we have what's going on right now. We have a lot of people ripping out Copeland compressors and putting a drive compressor on racks. Well, why rip off the compressor when you can take a variable speed drive and just put it on there right now? Pretty important stuff. Question?
I got a question. Take care of an ice rink. It's R22 system.
Yep.
Got 650 horse on it, 8 DPs. So you're saying I can take that and put variable speed drive?
Which model is it? 6?
8 DPs.
The 8D?
8 DPs.
I'll have to double check that. I don't know. I know in our AE bulletin it only says up to 6D. But get me afterwards and I'll find that answer out for you.
Those compressors have grounding rings on for use with the VFDs?
Well, I'm not sure about that question either. But I know for sure we have tested it in this range here from 25 to 60 hertz. There's no issues. Dave?
Trevor, the grounding rings are used typically for ball bearing type bearings. With ours being sleeve bearing, I don't think
Yeah,
it's necessary.
that's the difference. Yeah, because it's sleeve bearing. Yeah, that's exactly right. Thank you, Dave. Once again, check your AE bulletin, right? You can just automatically help your customers out and put a drive on it. One thing though, okay, I'll get to it in a second. Variable speed drive. So that's fixed compressors. We sell variable speed drive compressors, ZPV or ZPV. So they can go from, depending on the model, the range from 1,000 RPMs to 7,200 RPMs, right? To do all that capacity control. So we sell brushless permanent magnet motors. Okay, they're 6-pole. Do a whole course on talking about them. So here's the big thing. Digital versus fixed compressor. I get this all the time. Well, what's better? Is digital better or variable speed better? Well, advantage of digital, very simple to integrate and cost effective. That's the big thing. So we have lots of contractors that are putting drives on compressors, which is great, but one guy can work on them. So at 2 o'clock in the morning, when a mechanic goes out and he doesn't understand how to use the drive, they're just bypassing it. And we see a lot of applications like that. So the digital is more advantageous for the complexity side. But on the variable speed side, you know, you got better soft starting. And can be applied to existing compressor like we talked about, but more efficient in the partial load. So now you have to think about the application. Should I be using a digital or should I be using a variable speed on that Copeland compressor? Tandems, trios. Has anybody worked on tandem and trios before? Show of hands. So we got, oh yeah, a bunch of people. So basically what they are is a couple of Copeland compressors, discharge header, suction header. There's a few different models, different oils and stuff, how the oil is, tube and tube. But this is what I want to show you. The biggest question from contractors, well, do I have to replace the tandem set or can I just replace one? How many people say you always have to replace the tandem set? Show of hands. So 3 or 4 people. No. It's not the case. It all depends on the model of the compressor. It all depends if we have a service model. If we don't have service replacement, you're going to have to replace the tandem. Once again, get into the AE bulletins. Like 5 to 10 horsepower. This AE bulletin, so ZPT 100 to 182, replace the tandem. No tandem service replacement. And we might have updated this too. This is a little bit older slide. But then we get down to 20 to 40 horse. Look, you can replace the single compressor based on age. So if you have a 10-year-old, 15-year-old system in a tandem set and one compressor fails on a burnout, should you replace the tandem? Yes. Yes, right? Exactly, you should. But if it's only 6 months and one fails because of flood back, should you replace the tandem? Probably not. Are you learning something here today?
We have always been told to replace both of them, always.
Not the case. Not the case. If you had a... Oh, that's good. So right here, now you can teach someone. I want you to go and teach someone and print off these bulletins. Go in there and say tandem. Write in, like Don said, go to searches, write tandem, and it'll give you all the tandem AE bulletins and bring that to the guys you're working with.
This is a good slide to photograph, fellas.
That's okay. I can give you all the information afterwards.
Yeah, I think they're getting copies.
Go ahead.
Something I've done a lot is I'll take out Bristol tandems and I like to go back with a couple of scrolls.
Oh, well, awesome. Thank you. Thank you. I appreciate that. Okay, I got to try to hurry up here, but this is another thing. So you replace some tandems. If you read these AE bulletins, how many people unsweat a compressor when they're installing a new one? So a bunch of people. I've unsweated them, right? Because that's what I was taught. We do not recommend, Copeland doesn't recommend unsweating the compressor, especially for the tandem set. Never unbraze the manifold lines. Don't do it. I got guys have done it, and yeah, it works. They get by. But I've seen them where contractors unbraze them. 6 months later, the manifold breaks or gets a crack. Why do you think that happens?
That happened overheated recently.
Recently it happened to him. What is it?
Overheated too many times.
Overheated too many times, and they're like, oh, it's bad manifold set built by Copeland. That's not true. It's because you heated it up multiple times. You got to cut those out. And the guys, after they started, I've showed some guys, or the team showed some guys, and they cut them out, they never had that problem. Because there's a lot of torque. When that scroll starts up, there's a lot of torque, right? So there's torque, there could be torque on there. Okay, so that's for that. Any questions? We haven't even got to the presentation yet.
You had something?
Yeah, go ahead.
No, that just cleared it because I had a lot of problems off the manifold, and all the leaks, we would come back to it 2 or 3 weeks later, another leak.
Yeah,
It's all the torque and all the heating of it.
that's exactly what it is. Share that with someone, okay? Share that with someone.
Softer and softer.
And we'll say right in our AE Bulletin, do not, right here, that's why I wrote it. Cut the connections. Use couplings. And replace on age. This is very important stuff. You want to, for example, you got to go back multiple times. How much did that cost your company? And it's not your fault, I'll say, right? Because you don't know. If you don't know, you don't know. But now you know. So cut those out. And we say that for all the compressors. And you'll start seeing propane. If anybody does propane and you've ever watched any training video, you're always putting inert gas through there. And you should always be putting inert gas when you're welding on a system. Right? Okay. Causes and prevention. So now we're finally at the presentation. And I'm sorry that it took us that long, 2 hours. But I think that was that important? Do you find that was valuable? Okay. Excellent. Okay. Causes and prevention. Most compressors fail because system-related problems. A lot of people blame the compressor, but it's system-related issues that's causing the problem, failed compressors. So this is what happens. A contractor, even myself when I was in the field, go up to the compressor, take off the wires, ohm it out. Oh, electrical short, it's a burnout, right? Electrical failure. That's what it is. That's what we get. 80% electrical, 20% mechanical. The real cause is a mechanical failure. Electrical's second cause of failure. Mechanical is usually the first cause of failure. Okay? Field analysis pays off, or your compressors look like this, or like this. Okay? So, what are the 5 or 6 things that cause a compressor to fail? Overheat.
Washout, moisture,
Flood back.
Copper plate.
Contamination.
And vacuum.
Slugging. Flooded starts. Awesome. Awesome. Flood back, flooded starts, slugging, overheat, lost oil, contamination. We're going to talk about all these ones.
Just the one point I want to make, just to wrap your head around that compression ratio, for those that walked in that didn't know how to do it, the number one reason killer of compressors, by far, it's not even close, is overheat. And the number one reason for overheat is compression ratio. As Trevor said, the farther those numbers get apart, it gets hotter. Your discharge gas is not where it should be. Okay, 6 inches out. So.
Thank you, Don. Okay, what's liquid flood back?
We have liquid refrigerant coming back to the suction.
Okay, and how does that happen?
Low superheat.
Low superheat. Okay, exactly. Compressor's running.
No superheat.
Yeah, no superheat. Yeah. Compressor's running, and liquid returns to the compressor while it's running. That's flood back. Okay, or liquid dilution. What causes it? What does cause it? It's up there in the thing, but what causes it? What causes flood back? Some of the things.
Dirt on TXVs could be
TXVs, oversized, not sized properly,
air conditioning,
failed,
airflow.
low flowed, yeah, frozen coil, so many different things. So as the mechanic, you gotta think. Oh, I've had this failed compressor on flood back. One of these things caused it, and that's very important. You need to understand that stuff. Because you can't boil off that. If you can't boil off that liquid refrigerant in that evaporator, it's going to return back to that compressor. Okay? The way it works here on a scroll, so your suction comes in here on your suction side, you have oil, your oil and refrigerant come back cooling the motor, but if you start getting liquid refrigerant coming back, it goes up the flingers, and then it wears out the drive bearing bushing. And this is what it looks like. We call this scroll galling, and the bearing fails. So all of a sudden, if anybody hear a scroll go knock, 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 like knocking a bit? No? Yeah, you have? That's not saying it is. You have to cut it open to find out, but that's probably something going on here, because that's going back and forth. Your amps will be a lot higher too. Okay? Here's another picture of flood back dilution. You look inside the scroll set, there's nothing wrong with them. How many people cut open a scroll before? Show of hands. You have. You definitely should. If you work on scrolls all the time, take it back to your shop. Right? If it's an out of warranty compressor, it's going back to the scrap. metal place, cut it open. Look inside. Why did it fail? Because if you don't know why it failed, the next one, how long is that one going to last? That's how important it is. How long is that one going to last? Okay? So dry bearing furthest away from oil. So if you cut them open and you look inside and it looks like that, and there's a lot of, yeah, if it looks like that, a lot of scroll going on the thrust surface. So where's that scroll set? Just, so if you take a look at it and you look at the bottom here, and then this bearing, see how it doesn't even come out? When you got a damaged bearing, they just slide right out, right? And then you'll see a lot of circles on the bottom here. Okay, and then this is what happens. So all that liquid refrigerant comes out there, starts to wash out. And what do you think all this stuff is? Metal. And what do you think just below this thrust surface, right down here?
Windings.
Windings. So now you go up to the compressor. Oh, it's an open winding electrical failure. But really it was caused by that liquid dilution or floodback. Air cooled. Well, you got liquid refrigerant coming right in the head, and then what happens? What does it take? So you got liquid refrigerant coming right back into the head. What are you trying to do inside that? You're trying to compress, and then what does that cause?
Blown piston.
Blown piston, which we call a slug. Okay, could be liquid or could be oil, but we're talking about floodback. Then you look inside that cylinder and you'll see up and down wear, right? And if it's a larger one, and you'll look inside the cylinders and you'll see up and down on the air-cooled compressors, because you know that liquid refrigerant is going right inside the head and it's washing out that oil. Does that make sense? Okay, good. So refrigerant-cooled compressors, your suction's coming in. You have your motor right here. What does the motor do? What does it produce? A lot of what? Heat. A lot of heat, right? So you got some heat in there and you get a little bit of liquid refrigerant in there. Hopefully it'll boil it off. But you get large quantities of liquid. This oil pump will suck it up because we drill holes through our compressors onto our oil pump. It sucks up the oil, but if it's sucking up refrigerant as well, it starts to wash out all the bearings. It's something we call progressive wear. As you can see, the bearing is not as bad here. You look at the pump bearing looks probably perfect because that's where oil is. But by the time it gets to the last bearing, it's failed. Yeah, go ahead.
It's a good reason to replace crankcase heaters when they're failed on PMs and things, and not just look over them.
100%. What's your name?
Oh, Tony.
Tony. Thank you very much, Tony. Go ahead,
I
Don.
just want to back up one slide here. So again, this is an open check valve, but what this blue indicates liquid refrigerant coming back on this refrigerant cooled. It's heavier than the oil. The oil is showing you the oil itself, okay? The reason I point that out is that tube, the pickup tube that Trevor was talking about earlier, that's down here. Now it's pulling up mostly liquid refrigerant, as Trevor said, okay? That's what's going on there. Okay?
Thank you, Don. Yeah, exactly. So when that liquid refrigerant starts to get in there and start washing all that oil out, you're going to run into issues. And it leads to what type of compressor? A failed one, right? So progressive wear, what's this? What do you think this is right here? No. No, it's not. That's the bearing. The bearing shouldn't be on the crankshaft. It should be in the body. Okay? So I start to wear this bearing because of liquid dilution or liquid floodback. What do you think happens to the stator on the other end? It's on the same crankshaft. What?
Gets ground.
Well, it starts to drop. Right? And then this is what happens. Now you got a rotor dragging on your stator until you get it grounded. So now once again on a semi-hermetic you come up, oh, it's an electrical failure, but what just caused this failure? Floodback. And that's where you need to take these compressors apart and look at that stuff. Because if you just pull it apart, or if you don't pull it apart and you just pull it out and put it back in, you don't check, or don't notice it, because floodback could happen at any time, maybe after a defrost. So you set up your superheat and everything's great, but you have a defrost and then maybe that's when it happens, right? Okay, stator failure. Okay, hermetic reciprocating, same thing. That refrigerant, you're getting floodback, comes in and it starts to suck up liquid refrigerant, washing out the bearings again, which leads to another failed compressor. And this is kind of what it looks like when we cut them apart. You have this seizing onto the shaft. Anybody cut open a hermetic compressor? So like a CR and R, a couple of people, okay. Take them apart, learn, right? They're out of warranty compressors a lot of times anyway. Semi-hermetics, even if they're in warranty, tear them apart. Put them back inside. On scrolls, on the other hand, you want to talk to your distributor first before you cut open a scroll. If you know it's way out of warranty, if it's a 5-year-old compressor, that's out of warranty for sure, right? But if it's close or it's in warranty, contact your distributor and say, is this an in warranty compressor or not? If they say it's not an in warranty compressor, cut it open. Okay? If it's in warranty, I would talk to them. Guys, can cut them open if they're still in warranty, but you want to verify with your distributor first that if they need it back to check it, to inspect it. Because we inspect compressors on a lot of compressors.
And that's a good point on any compressor of ours. We have that 1-year warranty. If you have a compressor that fails within that 1 year, you can request a compressor analysis if you don't know that. Within that first year, it's free. Now, it's not a quick turnaround time. It might be, depending on time of the year, summer's going to be a lot busier. It might be 4 to 6 weeks, but you can get it. And outside the warranty, you can get one. And it may cost you $100. And we don't get into monies, but that's with your wholesaler. But it might be $100 is a lot cheaper than a $7,000 compressor, and keep replacing compressors. But just food for thought.
Thank you, Don. So, guidelines. This is a rule of thumb. Low temp, 2 to 8. 5 to 10 medium temp, and 6 to 12 high temp for superheat. But what you need to do is follow the original manufacturers. So the manufacturer of that evaporator is going to tell you, well, we want you running at 8 degrees superheat. We want you at 12 degrees superheat, or that plate heat exchanger. Right? They'll tell you what the superheat to be the most effective for that evaporator coil. Okay, things to prevent flood back. Well, Copeland recommends 20 degrees superheat at the compressor. So you can't always get 20 degrees superheat, right? If you're at a small plate chiller and you have the TX valve or the electronic expansion valve, you got the plate and you got 2 feet to the compressor and you're running at 10 degrees superheat. Are you going to pick up 10 degrees superheat to that compressor? No, you're not, right? So, okay, it's running at 12 degrees superheat. As long as it doesn't go to 0 degrees superheat, we're good. Right? But we would like to see 20. It's no different than a supermarket application. I'll get to you, Dick. Supermarket application. You got 300-foot pipe run, right? You're probably running at a 35 degrees superheat at the compressors. Dick, go ahead.
That was basically it. You were talking about the 6 to 8 and 2 to 6 and all that. Was that the evaporator?
That's the evaporator, 100%. You never try to adjust your TX valve for your system superheat, like your compressor superheat. 4 to 6 or 6 to 8 and 8 to 12. That's the evaporator superheat. So you should pick up some superheat along the way getting back to the compressor. Dick.
What's too much superheat back at the compressor?
You tell me, Dick, what's too much superheat?
I always thought over 40.
Over 40? Yeah. Depends on the compressor, right?
Depends on the temperature of the refrigerant coming back.
Yes, they're a max.
There can be a max.
65.
65.
Yeah.
65. But it all depends,
Inside,
once again, on the compressor, because I'm going to show you in a few minutes here, if you go over 20 on some, you're going to get a failed compressor. You go over 40 on some, you're going to get a failed compressor. It all depends on the application and depends on the compressor you're using. And then there's some additional cooling requirements for those compressors.
Just where Trevor showed you earlier, there's a new feature on that Copeland Mobile. You can hit that Copeland Mobile. If you go back in that diagnostic part and you can hit it, it will tell you the superheat and it will tell you what the return gas is, what it should be, okay? So just so you know, play with that Copeland Mobile. We're all self-taught and it's easy to it's easy to go around through that. Just start pushing things and you'll figure it out. It's pretty easy.
Dave.
Also, you want to look at the discharge line temperature and be below 225.
Exactly, for semi-hermetic.
If you have high suction superheat.
Yeah, so that's the best thing. Like Dick, as we talked about earlier, as that suction temperature starts to go up, what happens to your discharge temperature? That starts to go up, right? So as you start getting 40, 50, 60, that discharge temperature is going up. Those degrees as well, right? So that's where you want to do. That's the points that you have to check.
The only thing I other want to add, we don't really dictate superheat so much or subcooling because we don't know where that compressor is going in what application. That superheat we're setting there, that's if you're having trouble with liquid flood back, but it's at a high load condition. So that's at a high load condition because we lose more compressors on low load than we do in high load. At night when it cools down and you're low load, you more opportunity for that liquid refrigerant. Just food
Awesome.
for thought, yeah.
Thank you, Don. Okay, 404A minus 25 bucks. Suction gas temperature minus 30. Suction pressure is minus 40. Is this flooding back? No, it's not. 10 degrees superheat. Check the superheat. So I walked into a store one time, and every compressor, there's 5 of them on this rack, and they were frozen. There was 4 inches of ice on them. My heart was pounding because the whole store was down. I'm like, oh my God, there's something wrong. All these compressors are done. And I walk over to them, I'm like, they're all running, right? I check on the screen, and oh yeah, there's good superheaters. This is not the problem. So make sure you check your superheat. Very important. And understand how to check superheat. Right? How do you check superheat? At your evaporator.
Suction pressure and suction line temperature.
Suction pressure and suction line temperature. You go to a PT chart. And do you use the bubble point or the dew point on a PT chart?
Depends on the refrigerant.
No, it's dew point. 100% dew point. Especially if you're working with glide refrigerants or blend refrigerants, you'll get yourself in a whole world of trouble if you pick bubble point. You think you have 10 degrees superheat. If there's 10 degrees glide, you could be actually having 0 degrees superheat. So understand that you're using the dew point when you're checking superheat. Very important. Okay. One thing I didn't talk about. Semi-hermetic compressors. If you, one of the checks, and we're going to go through this today, what I'm going to get you guys to do, you're out in the field, you want to ohm out the compressor to see if it's electrically failed. You want to take off the head, inspect the gasket. That's what we're going to do, and I'll say this over again. Inspect the valve plate. Look inside the cylinders. See if they pump. Pull off the pump. Look at the pump gasket. Look at the pump bearing. And then one thing to do is shake hands with the crankshaft. If you got up and down play, what does that mean for that bearing? Yeah, it's war. And now that's why you're checking it and you got an electrical failure. That rotor probably drug on the bottom and you have a stator fail. Okay, always check compressor superheat. Look for signs of wear. Right? Take it apart. Take a look at it. One thing, if you walk up to a compressor and you look in the sight glass and it's full of foam or full of bubbles, what does that mean? Say a scroll, you go up to a scroll and you're looking inside and there's a nice oil, half sight glass oil, and all of a sudden you start seeing foam and foam and foam. What does that mean?
Contamination.
That's liquid. Flooding back. So that's one sign. You could just walk up to a compressor and look inside. Ooh, that doesn't look good. Figure out why that's happening. Is the evap coil dirty? Is the TX valve faulty? Is it set in properly? Okay, flooded starts. What's a flooded starts and how does it happen?
When liquid refrigerant migrates to the crank, I think it's the crankcase, right?
Exactly.
Starts, then the liquid expands rapidly and washes out all the bearings.
100%. Thank you very much. So that refrigerant, as a gas, travels through the system, migrates to the coldest part, which could be that compressor. That crankcase is not working that day. It stratifies inside the oil, and then you start up, and it explodes that refrigerant all over the insides of that scroll. Like this. So it migrates back, stratifies, and then you get an explosion. And it's loud. The compressor's loud. Okay, semi-hermetics, same thing. Migrates back to here, and that crankcase heater failed, and that's the coldest part, and it tries to start up. It washes the oil from everything. Right? Explosion. And then this is what happens. Air-cooled compressor. So it's erratic. It's not like the flood back, right? As you get that progressive wear. So this washes oil from anywhere, right? From any different parts. So inside of a scroll, remember I said on flood back, you look inside the scroll set. So we take it apart and we look inside the scroll set, and there's no markings. It looks like a brand new inside the scroll set. But when you look at the bottom, so you look at the bottom here, it's a real down. That's flood back. You get a lot of scroll galling here. If I open up a compressor scroll and I look inside and there's a ton of scroll galling just like this, I know that's from flooded starts. Because that explosion of refrigerant goes up inside the scroll set and washes out that film of oil between the scroll set. And then you're in a heap of trouble now. Okay? On semi-hermetics, a good, bad, good scenario. So progressive wear and flood back, but you can see here, this is the third one, right? That's you could see it sometimes when you're trying to get an oil pump off and the oil pump's stuck and you're trying to pull it off and you're banging and you get a screwdriver in there, a big one or a pry bar, and you pop it off if you can. And it was, the liquid refrigerant hit there first. This is where the first oil should be getting, right at your oil pump. If it seizes on there, that's the flood to start. Or here. So that refrigerant gets up there, explodes and washes all the oil out, and then you don't have that lubrication. Okay, maintain optimum refrigerant charge, use crankcase heater, great job. Locate compressor and control ambient if you can. Okay, use pump down cycle. Low pressure cutout should not be set lower than what the compressor is designed to operate. So this is one thing, when I was an apprentice, I was early in the trade and industry, and working on these racks, be honest, I was just thrown out there. Here you go, start working on this equipment. So I started working with some guys, and guys were like, well, Trevor, you're on a low temp system. What would you set on a rack? And anybody does rack here, what do you set the low pressure control for? What would you guys set it for, a low temp system? Anybody? Well, I was told set it to 2 to 5 psi. When it gets down, it cuts out. Right? Medium temp, 15 psi. Okay? But what the problem is with that is this is an operation envelope right here. Does everyone see this on the right side? Okay, that's an operation envelope. Copeland makes an operation envelope for every compressor. So we can help you guys know when you're running outside, and as well as the OEMs to design these compressors. So now, for an example, I'm using our product selection software here. At 100 condensing and 40 evaporating, which is 69 psi, running right here. This is what my design conditions are. So if it's a 10 TD on that evaporator coil, that's a 50-degree box. And this is the 40 SST, which is 69 psi. That's where it normally runs. If I set this one here to 5 psi, so right here it says 15 psi, this line right here is 15 psi, and I set it for 5 psi, what am I doing to the compressor now?
Killing it.
It's starting to, right? Higher compression ratio leads to higher what? Heat, right? More work. So now your customer's paying more money as well, right? If you want, you know, one of the rule of thumbs is, you know, start with 10 degrees below. So if you're running at 40, start with 30. But what do you have to check for? Not superheat. What happens if I only set it to 30? What happens to the pressure? Really quickly. Starts to rise, right? So then it starts a short cycle. So then you could try down to 20, which is 42 pounds. Because you don't want the short cycle and recycle a lot of times, right, as that pressure rises. You could actually just, if you want, put it right to 15, because you're still inside that operation envelope, right? If you put it down to 50 and all of a sudden it starts to rise really quickly, and you got a short pipe run, what could be an issue if it's a semi-hermetic? Bad valves. Awesome. What's your name? David. David, thank you very much. So if you pump down a compressor this far, you should pull out all that refrigerant out of that evaporator. That's the whole purpose of a pump down, right? So if you run it and run it and run it, and it pumps down, and all of a sudden it starts to rise, you could have bad valves. Another thing is if it runs and 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 doesn't make it all the way down here, once again, it could be something wrong with the valves. So you don't really have to get in and start doing these valve tests, because we don't recommend you pulling our compressors in a deep vacuum and then doing a hole test. Because I used to do that. I used to do that even before I came to Copeland. And I tell them about this and they're like, no, Trevor, that's not the way to do it. Do these different tests. Stay inside that operation envelope. So there's one scenario where you can run like a compressor outside the envelope. So we make compressors down to minus 40 or even minus 10 here. Say you're running at minus 10 with this compressor. Well, to pump down, you have to go outside the envelope. But that's a really small amount of time, right? So that's the only case, is like, then you can do it from minus 10 to minus 20. Because you're running at the borderline of that compressor. Right? Because if you just put it at minus 10, well, the compressor won't shut off, right? It'll just run. Yes, go ahead.
Question. I don't do much commercial refrigeration, but if you have a rack that has different temperatures, do you have racks that have different temperatures?
Yeah, you'll have a medium temp rack. There's just medium, and then a low temp rack, yeah.
So where do you put the pressure control at? Depending.
Oh, each compressor.
Okay.
Yeah, each compressor would have one. Okay. Yep. So does everybody kind of understand this? So if you set, instead of setting it all the way down to here, you only set it right to here, just say 0, you're doing less work on that compressor. right? So a good mechanic will set it, they won't set it right to the lowest. They'll know when that evaporator is has all the refrigerant out of it and it shuts off for the right amount of time until that system starts back up again. Okay. Slugging. Air-cooled compressors usually result from a flood back or uncontrolled oil return. Remember we talked about you get the suction and discharge right at the head. So if you got lots of oil coming back and you're trying to compress that oil, what do you have? You have slugging, busted valves. Yeah, you have a bad day. Right? You got refrigerant cooled compressors now is from severe migration, right? Because that compressor fills up with a bunch of liquid refrigerant from migration and it starts up and that liquid refrigerant gets up into the cylinders and does some damage. So as you can see here, if we pull off the head on one of these today and we flip it over and we see like little dents in here, right here, or a broken discharge valve. That's caused from liquid refrigerant getting up in there.
We found a wrench in this one.
Oh yeah.
Haven't had a wrench before, is that what you're saying?
Yeah.
So from a slug, you can see this, right? Broken discharge reed or broken discharge puck, the disc. Okay, so that refrigerant gets in there, boom, breaks it. So now what's happened? It's just on, let's say on one cylinder, it's a 3D compressor. So it has 3 cylinders and 1 busts. Is the compressor still going to run? It's still running. But what's happening now? What's going on right here? What's pushing on that piston now? Discharge pressure. So that one piston is fighting the discharge pressure of the other 2. Everybody following me right now? Okay. So what is this? What does this look like right here? What do you think this is? No, this is the piston. Okay? All our pistons have right here what we call the wrist pin. So this wrist pin connects our rod to the piston. So as it comes down and as it goes up, this wrist pin moves. And what do you think goes in between the wrist pin and the piston? Oil. Awesome. Chris, right? Thank you, Chris. So oil. So you're working away and your compressor's running fine. You take that slug that we just talked about and you have discharge gas pushing down on here. What do you think's happening to this wrist pin? Do you think it's moving up and down like it should? It's always fighting, right? So you're not getting oil on both sides. So you're getting oil here and then you get oil down here. Depending on the model of the compressor, there might be holes drilled through the rod. Okay? So now all of a sudden that discharge gas is pushing down on here and this is trying to push up. I'm not getting oil to my wrist pin. How many people heard of a semi-hermetic knocking? Knock, 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 knock. You have? Well, this is what happened. That wrist pin not getting the oil, fighting that discharge. So you come in as a mechanic and you're like, oh, found this compressor, pulled off the head. It kind of sounded a little funny. I pulled the head off, looked inside, and it was a broken discharge valve. Awesome. We can just replace the valve plate. And yes, 100% you can replace that valve plate and start it back up. But when you start it back up and you hear this knock, 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 your customer after a week or two is going to say that compressor needs to go. So now you just cost your customer a couple $1,000s to do a replacement, and now you have to change the whole compressor. If you have a wrist pin damage, you got to replace the compressor. How do you think you do a wrist pin test? So how do you shake it though? It's in the head, in the compressor. What do you got to do? What's the process? Does anybody know? Chris, can you explain maybe the process?
Pump it down.
So you pump down the compressor, take the head off.
Turn it on.
No, don't turn it on. Definitely not with the head off.
Well, that's what the guy told me.
What is it? Pump the top of the piston. So if you can't do it, like pushing down on it and it doesn't spin, you got to take off the oil pump. You got the head off anyway. You got to get a gasket. You got to go to the supplier and get a gasket for the head. You might as well get one for the pump. Pull the pump off. Turn them to each piston to top dead center and then turn it over just a little bit and push on it. If it drops down, you need a new compressor. If it doesn't, all you need is a valve plate and you save your customer a lot of money. Right? But if it runs and runs and runs and wears that wrist pin, you need a new compressor. Yeah, Dick. Copeland Mobile. Go right to the amp draw. You put in your suction and your discharge, and then that's how you do it. That's how you check the valve plates. Doing the pump down test, Copeland doesn't recommend it. And like I said, I've done it on dozens and dozens of compressors to see if they hold. But if you do that example where the low pressure control and the unit just keeps running and running and running, and you know it's not a long run, well, there's probably something wrong with the valves. Does that answer your question, Nick?
Yeah, it does.
Yeah, so you go on Copeland Mobile, you put in your suction, your discharge, like we talked about, put your amps in, and then if that doesn't match up, you're outside the range, there's probably something wrong internally in the compressor. Okay.
Trevor?
Yes.
Before you go away on that, if you have this damage here, your piston also will not go to top dead center.
Yep, this bad. Yeah, this bad for sure. Yeah, thank you, Dave. So yeah, you spin it around and it won't come all the way up. All right. Okay. So slugging, you get busted, blown gaskets, broken rods. So you pull off the head and you got a broken rod. It's a replacement. Back in the day, the guys could replace the pistons and stuff. You know, using feeler gauges. It doesn't happen real lot. There's contractors I know lots of contractors can replace pistons and replace internal, but the percentage is really small nowadays. It's because the cost of mechanic out in the field to try to do that and fix it properly far outweighs them buying a new compressor and putting it in. Right, so that's why our parts business from the 80s and 90s has dropped right off.
I've seen a piston broke in half, and that was one where they replaced the compressor twice.
Oh, so
Until they retrofitted the whole system, but it was old Carlisle.
Yeah.
Yeah, they did it twice.
So what could have been? What broke the rod? A slug, right?
And that's a perfect example. What he said was they replaced the compressor twice. That's a perfect example why understanding bill of materials are really, really cool. Because if you see like an 800 bill on a store that's only been there for 6 months, and you walked out there, a flag should be going up right away. It's not a compressor problem; it's a system problem. So.
Yeah. Awesome. Thank you. Okay. Why would you do this? Why would you do this? Why am I doing this?
Oil analysis, send it off for testing.
No, I'm not doing this. That's okay. Measure it.
Make sure
Okay.
the oil's coming back, there's no actually returning back to the compressor.
Exactly. Make sure your oil's returning. So one of my first year at Copeland, I went into the lab with a guy named Bruce Bosnell. Super smart guy. He's our inspection guy. I learned so much from him. And we get in there and we're doing this big scroll. And he's like, Trevor, can you measure the oil in this compressor? I'm like, measure the oil? Why would I measure the oil? Like there's a sight glass even on it. He's like, measure the oil. So write down first how much oil is supposed to be in that compressor. So I write down it, 46 ounces. So I get my measuring cup in our lab, Copeland Lab, pour it in, and this cup here, 32 ounces. 32 ounces. Almost 32 ounces. The compressor said 46. I had over 90 ounces in the compressor. That's an issue. And that was 90. And it was supposed to be 46. Okay? So now that compressor was replaced 3 times. It was a new contractor that took over because he was like, why did this fail? I just replaced it. He's a new contractor on site. Didn't know the site before because the owners hired another contractor to see what's going on because there was multiple failures. So what happened? The first contractor, original one failed. Then another one failed. Watch the oil. Then a third one failed. Or second replacement, sorry. And then this is when the other contractor came in and this one failed. Right? So look, here's where our pistons, and this is an example of a hermetic. But look, you get oil right in the piston so that, right? Question.
Yeah, I was just curious, so if your compressor has that much oil in it, when you pull it out, then how do you still have that much oil in the system? Because you're adding oil back into the system?
Okay, that's a very good point. So if somebody's changing it here and here, where's the oil at this point? Just changing it right here. And it fails. The first one probably fails on what? What is the first one you think fails on? No oil, which is what? What kind of failure? Seized compressor. Thank you. So the compressor seized. But you didn't get this one inspected, so you don't know. The guy didn't pour the oil out. Because if we would have dumped it out and it was supposed to be 10 or 20 ounces and there was 1 ounce in there, where's that oil now? It's somewhere in that system. Right? Does that make sense? Okay, so now he replaces this one here. He puts another one in and he runs it. What do you think the second one fails on? There's 2 things that it could have failed on. We're not even looking at this one. What? Slugging. So it could be slugging, or what was the first one we talked about? Low oil. Low oil. So the second one could have seized on low oil. Potentially. This is just an example. So now they replace that one again, and then what does that one fail on? Probably a slug. Right? Right? This could be a low temp application. What happens to oil when it's really cold? What does it get? Viscous. Very viscous. So it doesn't move the same. Right? So all of a sudden you got a really cold evaporator and your piping is not that great and it all stays in the evaporator. Okay? All of a sudden that defrost happens, pull all the oil back and then. So what you got, if the compressor's failed anyway, what you take is you drill a hole in the bottom over the proper cup, fill it up and see how much oil is in it. So there's some things that you need to look for though, because oil is one of the hardest things for me to diagnose. So if you go up and you see a massive leak and there's oil everywhere and then you check it and you're down 10 ounces of oil, well maybe it most likely leaked from that, it left the system from that leak, so you wouldn't pour any out. But if you have no leaks in the system, you pull out all the gas and then there's no oil in there, most likely that oil's in the system. You probably should drain a few ounces out of that compressor. That's why you've seen our recharge is lower than our OEM charge of oil. So if it's in the system, you know, and you're down 10 or 20 ounces, then maybe you have to pour some out.
Got 11 o'clock.
11 o'clock, whew. Okay, always measure oil if you don't have a sight glass.
What would be an efficient way to withdraw all that oil from the system?
Well, it depends where it's at. I was at one application. Well, we were doing a job and there was 4 coils in this walk-in box. It was a cooler box. 3 coils working perfectly. The 4th one wasn't, no temperature on it. So we pumped it down, and my journeyman at the time, because I was a young mechanic, he goes and he says, "Trevor, get me a drill." I'm like, "What are you talking about, a drill?" He takes a drill, drills it right through the coil. All of a sudden the oil started pouring out. Logged in 1 coil. I'm like, whoa, that's pretty cool. So we went up and we checked, and whoever installed it on this one here, was what way should your suction line flow? Towards the evaporator or towards the compressor? Towards the compressor. So we had to fix that problem. This is what could happen if you get lots of oil, right? Or a flooded start. Slugging caused by flooded starts, as well as this, right? You're taking liquid refrigerant oil and trying to compress that in the scroll. This here was done in our lab, but I've been on sites with OEMs. And I've watched watch them smash compressor. System's okay, we have an accumulator. Is it okay for flooded starts? Or so what does an accumulator protect against? How about that? Flood back, right? So it'll make sure that you don't get refrigerant in the compressor. Does it protect against flooded starts now? No. So if that compressor for some reason is colder than that accumulator, what's going to happen is that here's your liquid refrigerant. All of a sudden it's going to go into your pipe, migrate back to your compressor, right? If that compressor is colder. Another really important point is, and I got caught on this when I was a mechanic too. Had a 5-ton system, went up, a compressor was failed. It was a bad electrical burn. You could see the oil, you could smell it. So I pulled out the compressor, got a new compressor, pulled it down below 500 to hold it, put the new filter dryers on it, put a filter dryer on, an acid burn filter dryer, did all this thing, and I thought I did such a great job. It took me a couple hours longer than the job quoted for, but I'm like, wow, I did a good job. And that's one thing I want to tell you as a mechanic. If you got a job and it's a 4-hour job and that's what your boss quoted or the sales guys quoted, and it takes you 6 hours, but you do the job right the first time, that is way better than trying to cut it off, rushing, get it done in 4 hours, and you have 3 callbacks. Yes, the end user as well as your boss might be mad a little bit, but if you're fixing the problem the first time, a few hours in our industry, it doesn't make a difference. You're fixing the problem. The callback is what costs a lot of money. But anyway, get back to this job. I did it all. Thought I did it all right. I leave the site, I check all my my superheats through all loads. So when you're doing a system, you want to make sure your superheat, your discharge temperature, through defrost, through everything. You make sure through all the loads. 3 months later, I get a call from my boss. You got to go back to this Rexall it was. I go up onto the roof, and I got another failed compressor. I'm like, what is going on here? So I call up another journeyman, and he's like, is there an accumulator on there? I'm like, yeah, there's an accumulator. What kind of failure was it? Oh, it was a really bad burnout. He's like, your accumulator. What do you think happened? Clogged this up. So if you're doing a compressor replacement, you have an accumulator and you have a bad burn, you might think about replacing this. It's a cheap installation, because that callback costs a lot of money to my company, right? Because we had to eat the cost. I had to go back and replace it. So think about that if there's an accumulator on there and you have a bad burn. Learn from experience. Okay, remove cylinder head. Check for signs of slugging, broken suction, discharge. Field inspect. Big thing is field inspect these compressors, okay? You pull off a head and you see a broken rod, okay, you're going to replace that compressor. Okay, overheating. Causes of overheating: high compression ratio, like Don's been saying, low suction, high discharge, high return gas, high discharge temperature, high superheat, inadequate motor cooling, lack of external cooling, head cooling fan, demand cooling, DTC. So sometimes you need to add a head cooling fan to a system, or demand cooling if you're retrofitting gas. Overheat occurs when the oil in the compressor is heated beyond the way it lubricates. Okay? Overheating caused by oil breakdown chemically creates harmful carbon and acids in the compressor. Okay? So, some of the things that can cause overheat. Let's hear some of them.
Clogged condenser.
Dirty condenser. High superheat. Exactly. Plug dryers. Loss of refrigerant for the low suction side. High blocked or dirty condenser for condensing pressure. Overcharge of refrigerant. Non-condensables in the system. Okay. Here it is. This one is very important. Oil will lose lubricity at 300 to 320 Fahrenheit. Right? Dave said earlier back there, 6 inches from the compressor, 225 on our semi-hermetics. Right? Because inside the head, it's 50 to 75 degrees hotter. So now I'm in that danger zone. Is everybody following me? So now oil breaks down, POE oil at 350 will create contaminants and accelerate wear. So 6 inches from the discharge for semis should be below 225. Over 50 degrees Fahrenheit, check compression ratio. And lack of external cooling, like Don said, check this compression ratio. If you put your temperature probe on and it's 250. Is that okay? Note, I just said this, internal temperature is 50 to 75 degrees hotter. Okay, inside of a scroll, you get a lot of heat up in there, heat to the top cap. This is the floating seal. This is actually the seal ripped because of the heat. It's damaged seal. So is that compressor ever going to pump this scroll? That's not going to pump. Okay, then you look inside. So if you cut open a scroll and it looks super dry, that refrigerant through your system should always be carrying oil. Oil is always moving through the system with your refrigerant. You look inside the scroll set and it looks like this and it's super dry. Was there any oil in there? No. Okay. Heads. So if you pull off the head and it's super black like this and you can't rub it off, that is major, major overheat. But if you pull off a head and you can rub off it and it cleans off, that's mechanical wear. So that's your bearings, that's your wrist pins. There's something wearing in there causing your oil to turn black. Okay, blow by. So you get the overheat, it wears your cylinder walls, and it causes overheat to the crank and motor. And air-cooled compressors. So let's get to this point. I talked about it earlier. Remember I talked about the check valve inside our 3D, 4D, 6D compressors? So we have a check valve, free floating. What's this down in the below here? Does anybody know what these are? Oil pressure control, Syntronics. They're all called Core Sense now. Okay? So, I mentioned to you guys earlier that this is your crank should be higher or lower pressure than your body. What should this be, lower or higher? Lower pressure. Higher pressure here, 2 psi. That's what this vent valve is for. Okay, so now I got 2 psi higher. That oil, as it comes back, it flows. Okay, gets into my pump and everything's good. Okay. High discharge temperature, lack of cylinder wall lubrication. So now that's running. Piston and cylinder wall wear. Okay, then what happens? We got what we call blow-by. That compressor's pushing up, but all that discharge gas is pushing down by it, right? What happens to this right here?
Higher pressure.
Higher pressure in here, so what does that do? It closes. So where's all my oil now? Stuck right here, right? So this is filling up. And then what happens? What did I show you earlier?
You don't get any lubrication.
No lubrication, but what trips off?
Low pressure.
Oil pressure, right? My Centronic trips off. So you as a mechanic can call at 3 o'clock in the morning, you come in and you look at the sight glass, and what does the sight glass look like? It's oil, it's good. Oh, just a Centronic, it's a nuisance triplet. Oh, it starts up. 3 days later, one of your buddies go back and they go work on the thing. It was off on Centronic again. I looked inside, it was good. I pressed it again. What's the issue? Blow-by. Okay. So how do you check for blow-by? Does anybody know?
I'll say compression test, but
Okay, you'd say compression test. So I'm going to give you a tip right here. And I didn't know how to do this before I started working at Copeland. So, pressure. When you're checking oil pump pressure, you should always be doing on the crank. Most of the guys, and I've always done it on the suction. But you got to remember, it's always 2 psi higher. So when you're doing it on the crank here, you put a low pressure gauge there, low pressure gauge here. You slowly shut the suction service valve, and you watch the gauges. Gauges drop, drop. If this valve is overcome from blow-by or discharge gas, as it says here, this will stop dropping. What do you have to do with the compressor now? Replace it. Okay, so you'll watch the gauge just here. If the crankcase stops dropping and the suction continues, you reach the point that the piston blow-by exceeds the ability of the vent valve to vent to the crank, to the body.
so at that point, it means not only, I mean, that's one problem, but now you also have potentially another issue. I mean, your pistons obviously warp.
Oh yeah, well, you pull off the head and you'll see it. Yep.
So, but now you have more. I mean, so then you would chase it back. So you have more than one problem though, because now you had bad oil return, which caused your pistons to wear.
Oh, no, it wasn't bad oil return. What was the cause of that blow-by?
That was
What was it? What caused the wear of the walls and the rings?
Was that flood valve?
Overheating. Thank you. So that overheating, the lubrication properties got too hot. The oil got hot. They can't lubricate now.
Oh, I get it. Okay.
Now you're wearing those cylinders, and as a compressor is pushing that discharge gas in, closing this, you come in as a nuisance trip on the Centronic. Really, you got blow-by. Compressor needs to be replaced.
Yeah, and on that note too, I don't want to steal Trevor's thunder, obviously, but that is the thinnest film of oil in the whole compressor between the piston and the cylinder. So just that's what's going on there.
And then overheat causes shorted motors due to overheat. No lubrication in that stator and that rotor. Okay, maximum discharge temperatures, 225 on the semi-hermetics. Hermetics, depending on the hermetic compressor, look at the AE Bulletins, it could be 225 or 250. And scrolls, 267 inch from the compressor cell or 5 inches from the suction service valve if it has a suction service valve. Okay, set minimum superheat, properly set low pressure control, prevent loss of charge, maintain compression ratio design, have correct and adequate refrigerant charge, and use additional cooling method if required. Okay. Overheat protection devices that we have, lots of different ones, but this one here you can just put it on your suction line, wire it up, so if you reach that temperature over 225 or 250, it'll cut the compressor out, protect it. We have different devices like this, the TOD that we talked about, that if that temperature or amps go up higher, this bimetal disc opens up and shoots discharge gas onto that motor protector, stops the compressor from running. Well, this is the protector here, amps and temperature. This will open up. As that temperature rises, you're going to get overheat, shut that compressor down. Like I said, all these different compressors have different internals on them. You got to be aware which ones are inside that compressor you're working on. So here's a quick video. advanced scroll temperature protection. Anybody hear of this? So basically what this does, it's a device inside the compressor to stop it from pumping. So your temperature gets over 275, it stops from pumping. So the compressor keeps running. So you go up, put the gauges on, oh, it's not pumping, it's a failed compressor. It's not a failed compressor. If you see a sticker on it, like this, ASTP sticker, it says Advanced Temperature Protection Device, the compressor might not be failed. I've seen multiple ones come back. We put them on our test bench, they run fine. Most likely that temperature was too high. It opened this bimetal disc and shut the compressor down. Okay? I'm going to skip the video because I got quite a few more slides to go through. Optional for our core sense model. So if you work with any of our semi-hermetic compressors, you're going to have a core sense on the new ones. That's the way they come. Same with the old. If you're replacing it now with a service compressor, you won't have it on the service, only on the OEM models. So you'll have to take the core sense off the one that's on your system and then put it on your service compressor, just like the old Centronics. But in that core sense, you can put a discharge temperature probe. In North America, we don't sell the discharge temperature probe inside the Discus compressors. So what you have to do is talk to your wholesaler and say, listen, I got a bunch of core sense on my semi-hermetics. I want to protect my customer's equipment more for a cheap, or not a cheap, well, less expensive probe, then that's definitely less expensive than replacing a compressor. You could buy a ton of these and put them in all the compressors in the whole facility. So look into that. Additional cooling methods, super important. Discus cooling requirements, just to show you. This compressor at minus 25, a 4D, minus 25, 105, 50 return gas, R22, 338. 448, 449, 227. Big difference. But 338, what did we say oil starts to break down at? 225. 300, 320. We're way above that. Okay, refer to a dew point condition on PSS. So, R22 low temp applications require several sources of additional cooling. Discus cooling, like you used to have oil coolers. One of the compressors that we're going to tear apart has an oil cooler on it. We don't sell oil cooler models anymore. Okay, head cooling fan or demand cooling. 448 cooling requirements were advised to allow applications down to minus 25 without a head cooling fan and a head cooling fan below minus 25. This is for 404 refrigerant. Okay? Most racks, OEMs use a head cooling fan just as that precaution. And once again, reference these AE bulletins. Okay? Head cooling fan. So once again, we talked about those operation envelopes. When I'm running maximum of 65 degree return gas and I'm running minus 15 and 80, I don't need a head cooling fan with 404 or 507. But here, if I'm running in here, I need a head cooling fan. Make sense? Excellent. Talked about this oil cooler. If you don't have it anymore and it was on the old one, you have to add a bypass loop. Because if you don't and you cap it off like this, you're going to get another failed compressor. Here's another. This is the great point. Demand cooling. What is demand cooling? Does anybody know? Can anyone explain demand cooling to me?
Inject liquid refrigerant into the compressor to cool the discharge.
Yeah, so it injects refrigerant into the body of the compressor to cool it down. Everybody's okay with that? So this is 407, 448 now. This was 404. So now, if I'm right here in the operation envelopes, head cooling fan optional with demand cooling. So you need demand cooling on this compressor. When you get above this line here, demand cooling is going to inject. So now if you're doing a retrofit from 404 to a new refrigerant like 448, 449, you might have to start adding demand coolings on those compressors. Okay? Without demand cooling, head cooling fan required, right? 448, 449. You need to make sure you're right inside this zone for 110 and 60. If you're up here, a maximum of 40 degree compressor return gas. Okay? Does that make sense? So 65 is not going to do it. And then maximum of 20 degree superheat right here. That's with a head cooling fan. So you need to be aware of these applications you're putting in these compressors in, as well as doing this refrigerant retrofit. You might have to add demand cooling. Here's some of the Discus cooling. I'm not going to go through this. Check out the AE Bulletin, okay, to see the resistance of the ohms, as well as the piping for it. So you're taking a manual shutoff from your, what's this? What line is this? This is my condenser. Out of my condenser is what? Liquid line. So I got liquid coming back. It's flashed into the compressor. We're not throwing liquid in there. It's flashing refrigerant into the compressor to cool it down. Okay, DTC valves. So these are a temperature valve. So you got a temperature probe in the head, and when that temperature starts to rise, the valve will open up and inject some refrigerant in there to cool it down. Okay? We have electronic ones, and I don't know, they're not as popular. They should be, because they work amazing with electronic valves now on these ones for the DTC instead of the DTC. So, anybody here of an EVI compressor? Enhanced vapor injection compressor? Show of hands. So it's for efficiency. So the EVI, as you can see here, with 404, 507, EVI subcool low cooling oil. So this brings the efficiency up of your system. So we talked about compression ratio earlier, right? So what we're doing here on this compressor is we're taking gas, and if we're running just say 20 psi and 200 psi for an example, I'll just throw you that example out. On the side, this tube right here, we're pushing in 55 psi. So what does that do now to my compression ratio? It closes, right? So now I don't have such a big compression ratio, so there's efficiency gains there. But if I have an EVI and I retrofit the gas from 404 to a newer refrigerant that runs hotter, I got to use the DTC valve as well as the EVI. So there will be a T involved in there. Okay, so this is something you need to look at, because when we're changing refrigerant, now there's different dynamics in that system. Okay, loss of oil. Oil leaving the compressor must equal the oil returning to the compressor. So as that refrigerant is running, we're lubricating everything. Does this all make sense? Right, good. Oil pumped out during startup. Little or no oil returning to the compressor and proper oil charge. Lack of lubrication leads to oil not reaching the bearings and oil reaching the bearings but thinned out, like we talked about in overheat. Okay. Causes of loss of oil: poor piping, we talked about, traps, short cycling, low loads. Oil level in the sight glass. Why did oil safety trip? Right? Nuisance trips of oil failures. There's no such thing as nuisance trips. Something caused it to trip. This is an oil pump. One thing that you need to be aware of as a technician, you have on the side here a Schrader. On the top you put your oil pressure, or your oil pressure. So right here, your oil pressure point. If you pull this off, what's going to shoot in your face? Oil. Make sure you're always checking the oil pressure from the side here. So core sense, this is our oil style core sense. So if your oil pressure gets down below 10 psi D differential, it'll shut the compressor off to protect, say there's no oil. Okay, so that's the protection. So you got to figure out why. Is it a dirty screen? So it's pump outlet pressure minus crankcase pressure. So as you see, you put a gauge on here, you put a gauge on here, and then you subtract the two to get your net oil pressure. Okay? Crankcase pressure is not equal to suction pressure. We talked about that already. So where's a good level oil in a compressor? Half sight glass. There's some models where we say a quarter or some 3/4. Half sight glass. If you're looking at a half sight glass, that's what you're looking for. More oil is not always better, because that could be liquid refrigerant pushing up that oil too. What's this here? Does anybody know? Pick up screen. Okay. Should this be pointed down or up, this thing? And this is a big one, and I talked to lots of contractors about this. Should it be down or up? Up, you say? Down. But you can jam in the thing and just turn it on and have it pointing up. If it's pointing up, you're not getting all the oil. So if you do start to run on low oil, you're not getting that oil in there. So this should be always point down. There's a little tip on there too that it'll slide right in perfectly. Lack of lubrication. This is what it looks like. Scroll. Some more damage. Prevent liquid flood back. Prevent flooded starts when starting compressor. Give adequate time to run the compressors, no short cycling. Symptoms of low oil: excessive compressor noise and vibration, and excessive compressor amp draw. Contaminant, we're getting through there. We're getting through. There's quite a few cool things you're going to see here. Contamination. How many people heard of copper plating? Show of hands. What is copper plating?
When there's acid in the system and it causes some sort of electrical or some sort of thing with the copper, and it basically starts to, all parts of the compressor will start to look like copper.
Yeah, so what happens? POE oil. It's very what? Hydroscopic, right? So it absorbs moisture, right? So now if you got a lot of moisture in that POE oil and you start running heat in the compressor, heat starts to break it down, the oil. And then you get the acid. And then that's why you see it at the compressor, right? You see all the copper plating because that acid is going through the system, pulling copper back and putting it in the compressor. This is contamination, water inside here, different types of contamination. You know, lots of dirt in systems. I work on lots of supermarkets, and there's definitely times that I've pulled compressors apart and they were pretty gross inside. But copper plating right here. Make sure, what do you need to evacuate a system down to? As low as you can. So 250. If you can get it down to 250, perfect. And it doesn't rise up.
That was actually a teardown class I did. And Trevor saw the picture and he said, "Can you send that to me?" And,
yeah.
And one of the students actually took that as a souvenir when they left. It wasn't, but that's copper plating.
Okay, evacuate the system down to below 250 microns. Complete a hole test. So you do it, you shut it off, and you wait and to see if it rises up. If it rises all the way up and goes to atmosphere, well, then you probably have a leak in the system. If it rises up a few microns and stays below 500, you have a tight system. Okay. System cleanup after a motor burn. Well, use an EK filter dryer. So we sell filter dryers, premium filter dryers. But if you have a bad burnout, you might have to add a suction line filter dryer. This is for some old refrigerants, but permanent installations, you do not want the pressure. For an example, for 404 here, for low temp application, you wouldn't want that filter to go over 1 psi or you'll have to cut it out. Most manufacturers that sell filter dryers for burnouts, they'll tell you after so many hours you should be pulling that out of the system.
The reason that's so bad is because of the compression ratio, right?
There you go, bang on. You're right at the compressor now with a filter dryer, and all of a sudden your compression ratio, that starts to block up. Your compression ratio gets higher. And what did we say about compression ratio? It adds heat. Yeah, go ahead.
You're talking about vacuum. What do you recommend you get the vacuum down on compressor?
Well, it's all about the vac pump. If you can pull it down to 250, between 250 and 500.
I've been pulling them down to under 200.
Okay. That shouldn't be an issue.
Is there a load?
I don't know the answer to that. That's a really good question. I don't know the answer, but I can look that up for you.
I've never heard of it.
No.
For the microns?
Yeah.
Oh,
yeah.
We require 500 or less, but Anapion makes a product that goes down to 50 microns. So I don't think you can get down too low. There used to be a myth about pulling down too low, you break the oil down, but that's not necessarily true.
I had one get down to 24 microns.
Yeah.
Wow.
Yeah.
Okay, well, I don't know that answer, but I'll look that up for you. Find me afterwards and I'll send an email.
You're boiling water at minus 12 at 500 microns, so that's the whole purpose of it, right? We're trying to vaporize that moisture.
So here's some of the things that I really want to think. Reason for not inspecting failed compressors. I don't have time. That's not true. If you don't have time to do it now, do you have time to do it on the callback that you get?
Yeah.
Right? Emerson provides no charge inspections for warranty compressors. Like Don said, if it's in that warranty period, you go back to your distributor and say, I need an inspection. I don't know why it failed. We want to help you figure that out. Okay? If you don't know why the first compressor failed, how long will it take until the second one fails? The compressor failed because it's old or worn out. It's not true. Maybe less efficient, but it didn't fail because it's old or worn out. A properly selected and applied maintained compressor has a design life of 15 years. I don't know how to, and I love this. If you don't know how, ask somebody. And if this person that asks doesn't want to help you, ask somebody else. Talk to your wholesaler. They want to help you. There's over 500 Copeland technical specialists across the country, I believe. Is that around the number?
Yeah, you're close.
500 guys that we've trained that work at distributors across the country that want to help you out.
We're
So
actually
call
taking
them.
that on the road now, so it's multiplying by a lot.
Right? You don't know how to, ask someone. And that distributor that doesn't know, so you talk to them, and you find the answer, go back and give that guy the answer. And say, this is what I found out. Help each other out. Okay? This course is designed to help you with the skill set. All void warranty. Well, we want you to pull apart those semi-hermetics. Just put the parts back in. Okay? Everyone good with that? Okay. Emerson encouraged field inspection. We do compressor inspection report. I'm not going to go through it, but a compressor inspection report is what you would get back after you send in a failed compressor. Compressor system troubleshooting. I'm going to go through a few of these. You really need to understand the application. Okay? You need to, what are the design temperatures? We talked about it. Is it supposed to be 20 and 120 or 45 and 130, whatever? What is the required superheat and subcooling? You need to know this stuff. What type of refrigerant oil are used? It's very important. Understand the sequence of operation. When you start understanding the sequence of operation of a system and how it runs, okay, the thermostat closes, the solenoid valve opens, the low pressure starts to rise, the low pressure closes, contactor energizes, pulls into contactor, compressor starts. You want to know this stuff. Understand the system you're working on and how it works. It's going to make you a way better technician in the field. Is it a mechanical or electrical problem? Very important. Was it a floodback issue that caused it, or was it really a power issue that you had a brownout or low voltage that caused that compressor to fail? Is the line voltage correct? Are the wires intact? What's the amp draw if it's running? Is it right? Control voltage correct? What's the operating controls? Right? Is there safety controls? Are they bypassed? They shouldn't be. Is there a short or open and ground windings? Easy ones. These are easy ones that guys walk by all the time. Heat exchanger coils. Are they clean? Guys are going up and put gauges on a system, adjust the TX valve, and they didn't even go and look at the evaporator, the condenser yet. Go and check this up. What's the airflow? Is it correct? Don's motto is airflow, airflow, airflow. Right? Is it plugged up? Is the refrigerant charge correct? Superheat subcool. Is it within design? Is there restrictions? Is the component sized properly? I get this a lot. Guy comes in, change part like for like, goes back out. Well, that part was the wrong part that somebody else installed, and that's why you got another failed compressor. Right? Is the compressor operating efficiently? Okay. Different causes. We talked about all these already for high pressure and low pressure. Some more. These are good ones. Not caused by compressor. Low refrigerant charge. Low ambient. Major restriction. High evaporator load. Oversized meter type. Flash gas in the evaporator. Right? Most compressors failed because system-related issue, not because we sell broken compressors. I get this sometimes too. Contractor gets it, goes install DOA, dead on arrival they call it. Don, what do we do for every one of our compressors before they leave our factory?
Test to run them, and when they come back under warranty, we test to run them. And quite a few of them, I'm not going to get into the pie charts, but 30% of the compressors that come back on the scroll compressors, they run. And we classify that as NFF, no failure found. We literally fire them up in there, and a lot of it's got to do with the safety devices that people aren't aware of inside the scroll that Trevor went over. Yeah. So just food for thought.
So you got to be aware of that stuff, right? We test every compressor, so if you're getting a compressor that's not running, well, it does happen, right? Compressor maybe fell and got hit, banged up. Who knows how it shipped from our factory? But we know from our factory, and I walked through it many times, that we test run every one. And there's a huge procedure to get them out. So, system electrical issue, internal friction, high oil, turn-to-turn short, low voltage. Causes of low current, broken rods, worn cylinders, bad valves. We talked about all this stuff. Okay? Going to go quickly through the core sense technology, then we're going to get the compressors out here, and then we're going to have some people tear some of these down, okay? We'll take a break just after we go through this section.
Almost at lunch, 11:34.
Okay. So core sense, how many people heard of core sense? Show of hands. 1, 2, 3, 4. Awesome. Okay, we have many different core sense, but the ones that I'm going to focus on today is our Discus compressor and our air conditioning compressors. Okay, this is our core sense module. The way it works, if you get an alert, if you get low oil pressure, all of a sudden you got a flashy light. Do you think if the light's flashing green, is that a good or something you should look into? You got to look into. Low oil pressure, right? It's flashing. If it's on there solid, it's good. But if it's flashing, you have an issue. Performance alert. You can go to your wholesaler right now and buy these. If you have multiple compressors, 4 or 6D or 3D compressors, or large scrolls, you can buy a device like this that you can put on your compressor to protect your customer's compressor. And we're talking about $2,000, $3,000, $4,000 compressors. One compressor failure could pay for the whole site to have these electronics put on there. And these electronics, look what it protects against. High discharge, short cycling, missing phase, open or reverse phase. Then you can take a computer and log into it and see how many hours it ran, how many times it tripped off, how many times it locked out. And also you can connect to these two systems, like our E2 system. You can network to it. So you can remotely dial in to see how that compressor is running.
Trevor,
yeah?
Real quick, you can use this. Trevor actually gave me this idea from technicians up there in Canada where we go up and work together a lot is. You can also use that as a service tool. You don't have to permanently leave it on there. If you've got a problem child compressor, if you will, and you can't catch the problem while you're there, pop that on there, come back, download the information. It'll tell you what's wrong with it, what's going on.
Yeah. So this is the air conditioning model. They work the same. They have different trip points. Like this one doesn't have low oil, but same thing. You'll get a flashing light. You read that code and then you look it up. Lock out or trip. Scroll high temperature on 4. So we have software, so you can go to our online product information, and in the online OPI is called, you can download the refrigeration software, the air conditioning software, as well as our residential software. So you can dial into these compressors and find out what's going on. So here's online product information at our website, www.climate.emerson.com. Has anybody been to that website before? Show of hands. Okay, a few people. You want to start learning? Start going to this website. Check this out. There's so much good information on there. So you click on OPI. It's free to everyone. You click on software downloads, and then all of a sudden you get all the software here for free to put on your computer. Connectivity. So you do need to have a RS-485 to USB cable, so plugs into your computer, and it's on Modbus language. So you plug it in, and then with the software you can communicate to it. Same with this one. Same with this one. Okay. Networking. So you can daisy chain all these back together to a control platform like our iPro Rack or our XWeb and get all that data remotely. Or our E2 platform. Daisy chain them all back and remotely log into these compressors to see why they're running, what's going on with them. When did they trip? Why did they trip? And you don't need a computer to hook up to them. You can read it from the different platforms. Accessing the information. This is super important. So here you hook your computer up to the CoreSense module, you load the program up, and this is what you need to do. You just press start. Okay, as long as it's wired up properly and your dip switches are right, but you look in your AE Bulletins, you press start, all of a sudden 3 modules found. You stop that and you close it out. And then what you're going to see is them communicating with 3 different devices. And as you can see, we're responsive receive. So you click on one of them. We're going to click on the CoreSense protection. And this is the information you have. So if it's running, if you got alert status, if the motor protector's tripped, right? And then the sensor's inside. Then it tells you the discharge line temperature here. Okay? Then we go in. You can change the model number or the serial number if you need to. And these are all matched. So if you ever come up to a compressor and you see the serial number is different, that means that compressor is what? It's been replaced. Excellent. Then you can change some settings. If you don't want it to trip out at 310, you can get it at, say, 270 inside that head and protect that compressor a little bit earlier. As well as voltage imbalance if you want. But here's where all the cool information is. As a mechanic, if you can go out and see how long that compressor's been running, how many times it started that day and how many times it stopped, if it tripped, right? This is such great information. Like right here, this compressor ran for over 8,000 hours and it started 732 times. Is that valuable as a technician? That's really valuable. And then it tells you, look, 24 hours it ran. How many times did it start that day? 0, because it's full running. Look, all of a sudden it's running. Now, all of a sudden it started to stop run. And look at this, low oil pressure, 7 times. Right, so now it's telling me, so if you came up to a system and you didn't have this, you're going to search for a little while, start the compressor up and try to figure out hopefully check your net oil pressure, and then you'll learn. But right here, all of a sudden, right off the bat, there's something going on with the oil.
What's the one that's tripped 47 times?
That is motor temperature trip 47 times.
What's the last word there?
Connection loss, so that's the transducer.
On the motor temp, says motor temp trip something. Okay.
Control module.
Okay.
Yep.
So is that?
There's a bunch of different ones. So the best thing to do is, be honest, get to the AE Bulletins and read. Or download that app that I talked about, HVAC Fault Finder. All this is in the HVAC Fault Finder. You use that app to tell why those compressors trip. So if it flashes 3 red on the CoreSense module, and you do 3 red on that app, it's going to tell you low oil. And it'll give you troubleshooting scenarios and what to check. Well, yeah, go ahead.
One quick thing about that app too, we didn't do a demo on it. It is the answer key to the CoreSense, but if you don't have CoreSense, you can push no module on there and it will still give you a flow chart of what's probably going on with your compressor, just so you know, okay?
Okay, we're getting through this. So if you want a data log now, just say like Don said, you have an issue with a compressor and you can't figure out and you use that performance model. You can start data logging what's going on with that compressor. What's the discharge temp at 2 o'clock in the morning? Right, so now you're trying to monitor the system. Was that the time that the end user left the door wide open, or washing out the coil and freezes the coil up, something like that? Washes out the oil of the compressor because you're getting a little bit of flood back. That's why it tripped on oil. Putting these things together from a device like this. I know it's hard to see, but this thing here, I had to go to a job site for an OEM. Contractor was in there and said, oh, CoreSense is no good, it's terrible. My compressor won't run because this CoreSense thing. I'm ripping it out. So they had it bypassed. So when I went there, I went and took a look. The first thing is that I hooked up my module. Scroll high temp trip. Oh, sorry. Motor temperature thermistor, open or short it. Trip 42 times. Motor high temp trip 78 times. Motor temperature lockout 5 times. So he's telling me this is a problem with the CoreSense. What was the CoreSense doing? Doing its job. How do you think you reset a lockout? Kill the power. So how many times did this guy go back there, or this person, whoever it was? 5 times. And so I went there with my application engineer, I went there with the OEM, that contractor wasn't there, the facility management. What do you think was the first thing that I went and looked at? And this is a massive air handler. What do you think was the first thing I went and checked? I went and checked the condenser. I could not even see a fin in the condenser. I told the maintenance guy, go in there, he touch it, it's just start rolling down like this. Okay, so that's why CoreSense is an advantage to have those and look at them on your Copeland compressors. Okay, I'm so sorry that it took so long. We're at what time now? Quarter to 12. So if anybody wants to come back, what we're going to do, we got 15 minutes. We're going to do a break right now to pull in the compressor. So if you want to come back, and what time should we start?
Well, they get 12 to 1 for lunch.
12 to 1?
One's coming in here, but there's other,
Yeah, there's other events. So if you want to come back in 15 minutes, we'll start at 12. I know it's going to be in your food break. We'll do the teardown. Okay, it's up to you guys if you want to come. I'm real sorry that we went over. But we're going to do that teardown, okay? So anybody who wants to come, you're more than welcome. And if we get volunteers when they get back, you're going to do the teardown.